All right. Good evening, people. Good evening, good evening, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing amazing, all of you are doing great. Yes. So, my dear students, you can let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats, everyone, if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly in the chats, quickly in the chats, quickly in the chats. Quickly in the chats, people. So, in the yesterday's session, we are done with your class 12 physical chemistry, right? And today it's going to be just the question practice of your class 12 physical chemistry. Okay? And my dear students, whatever questions can be framed from class 12 physical chemistry, I'll be showing you all of them. Okay? All of them means all of them. Whatever types of the questions can be framed. Okay? Yeah? And at the same time, I'll be sharing the PDF of this particular session on the Telegram channel. I hope you all are the part of the Telegram channel already. The name of the Telegram channel is WASSIM. What is the name of the Telegram channel? Wait, I need to check. I forgot. Okay, yeah. It's Wassim but Chemistry Official. Yeah. Okay. My bad. This is the name of the Telegram channel on which I shall be sharing the PDF of this particular session as well. Okay? Perfect. So, my dear students, can you tell me how many of you joined the yesterday's session? I just want to know first. How many of you watched the yesterday's session? Let me know quickly in the chats. People are asking about the duration. The duration is going to be 3 to 4 hours. Don't worry. 3 to 4 hours. Perfect, 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 perfect. Perfect. Okay. And one more thing. Before starting the session, I hope you know it. If I open this particular channel, your Unacademy NEET English channel, if I go into the live category, in the live category, 2 more sessions are scheduled. First of all, tomorrow you have got Yavar sir session, complete class 11th physics part 1. Day after tomorrow, it's going to be top 300 questions of class 11th physics by Yavar sir only. And then on Sunday, I think the timing mentioned here is wrong. Okay. This session is on Sunday exactly at 10 a.m. Okay. This session is exactly happening on coming Sunday at 10 a.m. Okay. I'll be taking your complete class 11th in organic chemistry. Just give me a second. I'll just change the timing of this particular session. Just a second. Till then, I would want everyone to smash the like. Right now, there are 270 people watching. Go to this session. I want 270 likes right now. Till then, I'll just change the timing of this particular session. Just a second. It is 10 a.m., right? 10 a.m., 10 a.m., 10 a.m. February 8th. Today is Thursday. Calendar. Where are you, calendar? February 8th. February 8th is Sunday. And it's saved. I think yes. Yes, perfect. Perfect, 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 perfect. Just give me a second. Okay, are you done with this? I told you a lot. What is this? Just 58. There are how many people are watching? 256. I had told you to make it as how much? Guys, I told you to smash the like on this session, on this complete inorganic class 11th chemistry. Yeah? Where are you? Are you here? Are you here? Are you here? This particular session I'm talking about. And click on notify me right now in front of me because I don't trust you. Click on notify me right now. Let me check. Are you actually listening to me? Are you listening to me? Yeah, of course, trust issues. Yeah. So the session which I'm taking on Sunday, this complete inorganic chemistry class 11th, it is in the live category. Go right now and click on notify me and do not forget to smash the like as well. Let me check how many of you have done it. From now onwards, I'm going to do it like this only. Nice, I like it. Not everyone has done it. Till all of you do it. Till then, I'm not going to start the session. Priyadarshini, tomorrow I'll be taking the session in the Dream Crash Course batch, okay? Don't worry. Okay. Are you done? Let me check it again. Not everyone has done it. Not everyone has done it. Okay, should we start, guys? And before starting the session, what do? I ask you one simple question. Which part of the country you guys are watching me from? I just want to know in the chats first. Which part of the country you guys are watching me from right now? I just want to know. Well, I'm live from Srinagar, Jammu and Kashmir. I'm live from Srinagar, Jammu and Kashmir. Which part of the country you guys are watching me from right now? I just want to know. I just want to know. Quick. Quickly. All right. We have a lot of people from Andhra Pradesh, AP, Pune, Kashmir, Pondicherry, Anantnag, Karnataka, Pondicherry, Andhra Pradesh, okay, Tamil Nadu, Bihar, Srinagar, Kerala, Kashmir, Bangalore. The chats are stuck somehow, but the chats are moving on my other screen. Assam, Manipur, Chhattisgarh, okay. Wow, amazing. Amazing people, amazing. Amazing. West Bengal, Telangana. From your heart, yeah? Your life from my heart. Okay, should we start then, guys? Got it, got it, got it. Should we start? Should we start? Perfect. I hope all of you are ready. So, my dear students, we are starting then. Let's get going. Let's get started. And the ones who have not subscribed to the channel yet, I would want every one of you to subscribe to the channel right now. Okay? And at the same time, tomorrow in the evening, I'll be posting a very, very, very important session. Do watch that. The session duration is going to be just for 10 minutes. Okay? 10 minutes. I'll just tell you the title of the session. It's 200 marks in 7 days that I'm posting tomorrow exactly at around 8 p.m. Okay? Do watch that. Chalo guys. Let's get going. Let's get started. And let's start with the first question from the chapter Electrochemistry. Look at the question carefully, guys. Look at the question carefully. The question is directly taken from your NCERT. Okay? Look at the question carefully. Represent the cell in which the following reaction takes place. Calculate E cell if E naught cell is equal to 3.17 volt. This is the first question which is on your screen. So first of all, this particular question will teach you how do we represent a cell. And yesterday we have seen in detail how do we exactly represent the cell. My dear students, first of all, if I ask you what is the oxidation state of magnesium, what is the charge on magnesium? 0. What is the charge on silver? It is +1, right? What is the charge on this magnesium? It's +2. And what is the charge on this silver? It is 0, right? What is happening to the oxidation state of magnesium? Is it increasing or decreasing? 0 to +2, increase in the oxidation state. Increase in the oxidation state is what you call as oxidation, right? And oxidation takes place at anode. So your magnesium is going to behave like an anode. Your magnesium is going to behave like the cathode. That means your silver automatically is going to behave like the cathode. So first of all, how do I represent the cell? I am going to make two parallel lines in the middle. I'm going to make two parallel lines in the middle. And my dear students, these parallel lines, what do they represent? They represent your salt bridge. I hope you know that already. They represent your salt bridge, these two parallel lines. Now, on the left side of the salt bridge, what do we have? What's happening? Just a second. Okay, on the left side of the salt bridge, what do we have? We always write the anode. And at anode, what happens? Oxidation. Magnesium solid is getting converted into Mg di positive. So it's going to be Mg solid getting converted into what? Getting converted into Mg di positive aqueous, right? On the right side of the salt bridge, we write cathode, and at cathode reduction takes place. Ag positive is getting converted to Ag solid. So it's going to be Ag positive aqueous getting converted into Ag solid. This is how you first of all represent the cell. Point number 1. Point number 2, my dear students. What am I supposed to do? I'm supposed to calculate EMF of the cell. How do we calculate EMF of the cell? We calculate EMF of the cell with the help of Nernst equation. You know, E cell is nothing but it is E naught cell minus 0.0591 divided by N log of QC, right? So E naught cell is given to me in the question. E naught cell is given to me in the question. What is the value of N? Look at the reaction carefully. 0 to +2. So loss of 2 electrons, right? So N value is 2. N value is 2. N value is 2 given in the question. What do I just need? I just need the QC value. Yesterday, I've taught you how to write the QC expression. We always start with the product. It's going to be concentration of Mg di positive, raised power stoichiometric coefficient, that's 1. This Ag is in solid form, its active mass is unity, nothing to do with that, divided by. This is in solid form, nothing to do with that. This is Ag positive concentration, raised power, its stoichiometric coefficient, that is 2. Now, the concentration of Mg di positive, 0.13, divided by concentration of Ag positive. It is 10 raised power minus 4. 10 raised power minus 4 ka square comes out to be 10 raised power minus 8. So you got all the values. You got all the values, people. Right? You got E naught cell that was given in the question. You got N value. You got QC value. You just have to put the values into this equation and do the calculation. Well, calculation I'm keeping to you so that you can try it out. Okay? Calculation part I'm keeping to you so that you can try it out. Otherwise, I know you're going to just see the question. That's it. Okay? Perfectly done. I can see majority of the students are coming up with the answer as 2.93. So if majority is coming up with 2.93, I believe the answer is going to be correct. 2.93 only. Okay? Moving on to question number 2. Look at this particular question, guys. Look at this particular question. Calculate the equilibrium constant for the reaction. The reaction is given. E naught cell is given. We need to calculate equilibrium constant. My dear students, if you remember, your Nernst equation at equilibrium, what is that? That is E naught cell is equal to 0.0591 divided by n log of equilibrium constant. Log of equilibrium constant, right? Perfect. Now, my dear students, what is E naught cell? E naught cell is given to me as 0.46 is equal to 0.0591. What is the value of n? Look at the reaction. 0 to plus 2. 0 to plus 2, loss of 2 electrons. So n value is 2. N value is simply 2. And it's going to be log of KEQ. Log of KEQ. Perfect. Right? Now, 0.46 into 2 comes out to be 0.92. 0.92 divided by 0.0591 is equal to log of equilibrium constant. I hope things are clear till here. I hope things are clear till here. Right? My dear students, when you solve this particular term, what do you get? You get log of KEQ is equal to approximately this value comes out to be 15.6. Approximately. This value comes out to be 15.6. Okay. Now you must be thinking, how do we solve this particular equation? How do you solve this particular equation? My dear students, log of KEQ is 15.6. That means KEQ will be equal to NT log of 15.6. NT log of 15.6. Now, the point is, how do we solve NT log of 15.6? How do we solve NT log of 15.6? See guys, 15.6, just break it as 15 plus 0.6. Broken down as 15 plus 0.6. Now, this 15, just write it as 10 raised power 15. Just write it as 10 raised power 15, right? Multiplied by 0.6 is log of what? 0.6 is basically log of 4. 0.6 is log of 4, right? So the answer is simply 4 into 10 raised power 15. Perfect. Right? For example, one more example I'll take here. See, the approximate answer of this question is 4 into 10 raised power 15. This is the approximate answer. My dear students, I'm pretty much sure majority of you would not be knowing how to calculate the NT log. So let me quickly show you how to calculate NT log. For example, you have to calculate the NT log of, let's say, 4.3. NT log of 4.3. Okay, how do I calculate NT log of 4.3? Just break it as 4 plus 0.3, right? This 4 over here, write it as 10 raised power 4, multiplied by 0.3 is basically log of 2. So it is 2 into 10 raised power 4. Understood? Simple, as simple as that. I'm moving on to one more question. My dear students, look at this particular question. The standard electrode potential for a Daniell cell. Standard electrode potential for a Daniell cell, right? The standard electrode potential for the Daniell cell is 1.1 volt. Calculate the standard Gibbs free energy change for the reaction. So my dear students, I'm supposed to calculate delta G naught. Yesterday I've told you delta G naught is equal to minus NF E naught cell. Perfect. Minus NF E naught cell. Now, starting with minus, N value. 0 to plus 2. Loss of 2 electrons. So N value is 2. Faraday is constant. 96500 coulombs. Faraday is constant. 96500 coulombs. E naught cell is given to me in the question, 1.1 volt. Perfect. Now, since I've used all the parameters as per SI system, so I will be getting the value of delta G naught as per SI system as well. And delta G naught unit as per SI system is joules. For example, if they ask you to calculate in kilojoules, so you'll be simply dividing with 1000 and you'll get the answer in kilojoules. Done, understood? Okay. Perfect. Moving on to the next question. My dear students, look at this particular question. Carefully. The question is calculate the potential of hydrogen electrode. They are asking you to calculate potential. But which potential? Oxidation potential or reduction potential? Whenever you see a question like this, whenever in the question, they don't clearly mention whether you have to calculate oxidation potential or reduction potential. They just tell you to calculate the potential. Potential means reduction potential. That means you have to calculate the reduction potential of the hydrogen electrode. Okay, you have to calculate the reduction potential of hydrogen electrode. And my dear students, in order to calculate reduction potential of hydrogen electrode, reduction happens at cathode, right? So I'll make sure that hydrogen electrode behaves like the cathode. And when hydrogen electrode behaves like the cathode, what happens? A reduction takes place. A reaction I gave you yesterday. When hydrogen electrode behaves like the cathode, reaction is going to be like this. 2 times H positive aqueous plus 2 electrons. Gives what? Gives H2 gas. Gives H2 gas. Perfect. This is the reaction. All right. Now, my dear students, what is the N value here? N value here is 2. If I want to write the expression for QC, QC is going to be pressure of H2 raised power 1 divided by concentration of H positive raised power 2. Perfect. Now, since in the question they have not mentioned the pressure of H2 gas, so let's take the pressure of H2 gas exactly as 1 bar. Let's take the pressure of H2 gas exactly as 1 bar, since they have not mentioned it. What is the concentration of H positive? In the question, they have mentioned pH. pH is given to me as 10. And if pH is given to me as 10, that means concentration of H positive would be 10 raised power minus 10. Simple. So this is 10 raised power minus 10 plus square. Perfect. So it comes out to be 1 divided by 10 raised power minus 20. So the value is 10 raised power 20. This is the QC value, right? What do I have to calculate? I have to calculate the reduction potential. Perfect. I'll use the Nernst equation. I'll write reduction potential is equal to E naught RED. E naught RED minus 0.0591 divided by N. Then it's going to be log of QC. Log of QC. Perfect. My dear students, in case of hydrogen electrode, SRP as well as SOP, both are 0. So standard reduction potential of hydrogen electrode is already 0. I just have to calculate ERED, which is minus 0.0591. N value is 2. Log of QC. QC is nothing but 10 raised power 20. Perfect. Now just the matter of calculation. Just the matter of calculation. Right? Just the matter of calculation. Sir, bring NEET JEE level question. What is this? This is the NEET JEE mains level question only. Okay? This is not something which you get in class 8th. This you get in JEE mains. This you get in NEET also. Okay? Alright. So this is minus 0.0591 divided by 2 log of m raised power n, which comes out to be n log m. So 20 comes to the front. Log 10 is 1. So the final answer is going to be minus 0.591 volt. Am I clear with this? Am I clear with this, people? Everyone? Okay, so this is what you call as the reduction potential of the hydrogen electrode, which you were supposed to calculate. I want the chats to be continuously moving. I want you to solve and give me the answer in the chats continuously. You don't have to stop. Otherwise, the session is going to be boring otherwise, right? Question practice session is always boring. Okay, but we can make it interactive if you could solve the questions and keep on writing the answers in the chats. Yeah? Perfect. Let's move on, guys. Let's move on. Let's move on. Look at this particular question. This again your NCERT in text question. What do you think about this? Look at the question carefully. The question is calculate the EMF of the cell. The cell reaction is given to me. Perfect. We have to calculate given that E cell is equal to this. Right? So this is technically, this is a printing mistake, I believe. This is E naught cell, which is given to me. 1.05 volt. Now, my dear students, first of all, Nernst equation says that E cell is equal to E naught cell minus 0.0591 divided by N log of QC. In the question, they have given you E naught cell, right? What is the N value? See, nickel goes to nickel dye positive. So 2 moles of electrons are lost by nickel. So N value is 2. What do I have to calculate? I have to calculate QC. QC is going to be, start with the product. It's going to be concentration of nickel dye positive, which is 0.16. Raised power stoichiometric coefficient, that's 1. Silver is in solid state, nothing to do with that. Divided by this nickel, solid state ectomass unity, nothing to do with that. Ag positive concentration, that is 0.02. Raised power, it's stoichiometric coefficient 2. So from here, you will get QC. So you got QC, you got N, you have E naught cell given in the question, put the values and get the E cell. That's it. Right? Put the value, get the E cell. I believe this is clear to everyone. Okay? Now, my dear students, let's move on to one more question. Let's move on to one more question. Just give me a second. Look at this particular question. If you remember this sort of the question, this question we solved yesterday also. This question we solved yesterday also. Right? Quickly. Quickly, guys. So if you look at the question carefully, we are given with lambda naught m of NaCl. lambda naught m, molar conductance at infinite dilution of NaCl is given. How much is that? Leave that aside. Lambda naught m of HCl is also given, right? And this is NaAC. AC means acetate ion. AC means acetate ion. Acetate ion means CH3COO negative. So this is technically lambda naught m of CH3COONA. This is technically lambda naught m of CH3CONA. All these values are given to us, right? The first one is 126.4, second one is 425.9, third one is 91 Simon centimeter square per mole. We have to calculate lambda naught m of, this is acetate ion, CH3COO negative, and this is H. So technically we have to calculate lambda naught m of CH3COOH. And my dear students, if you know lambda naught m of CH3COH will be simply lambda naught m of CH3CO negative plus lambda naught m of what? Lambda naught m of H positive. Correct? Now, yesterday I gave you one simple trick to solve this particular question. See, what do you need? You need CH3CO negative and H positive. Is CH3CO negative anywhere? Yes, CH3CO negative is here. Is H positive anywhere? H positive is here, right? So I'll just add these two and I'll be subtracting this one. So if this is equation 1, this is 2, this is 3. So I'll be adding 2 and 3 and subtracting one from it. So I'll be adding 2 and 3 and subtracting one of it, right? So 2 means 425.9. 3 means 91. Minus 126.5. Solve this. This is going to give you the molar conductance at infinite dilution for CH3COH, right? Yes? Right, people? Am I clear? Am I clear? This is the way you solve this particular question. Well, majority is saying 390.5. I believe you. The answer is going to be 390.5 only. Okay? The answer is going to be 390.5 only. Look at the question. Look at the question, guys. Look at the question. We are solving the question chapter-wise, guys. Chapter-wise we are. So right now we are doing electrochemistry. Look at the question carefully. The question is, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at cathode? This again NCERT example question. So first of all, we are doing the electrolysis of copper sulfate. What is the mass of copper deposited at cathode? Now at cathode, what is the reaction which you do? What is the reaction at cathode? At cathode, reduction takes place, so copper dye positive will be getting 2 electrons and will be getting converted into copper solid. So copper solid is deposited at cathode basically. You know that already. Copper solid is deposited at cathode. You know that already. Now, first of all, the mass of copper solid deposited will be equal to equivalent mass of copper multiplied by I multiplied by T divided by 96500. Faraday's first law. Simply I'm using, nothing else. Right? Now, first of all, what is the N factor of copper here? How do we calculate N factor of copper? How many electrons do you see? 2. What is the stoichiometric coefficient? 1. So 2 divided by 1. That comes out to be 2. Okay. So my dear students, equivalent mass of copper means molar mass of copper divided by N factor of copper multiplied by 96500. Current of 1.5 amperes is going into the solution. For how long? For 10 minutes. So it is 10 multiplied by 60 so that you convert in seconds. When you solve this, you'll be getting the answer in grams. This is the mass of copper deposited at the cathode. Right? People are saying 0.296 grams. I believe you. The answer is 0.296 grams. Moving on. Moving on, guys. Moving on. How much charge is required for the following reduction? How much charge is required for the following reduction? First of all, you want to convert 1 mole of Al tripositive. You want to convert 1 mole of Al tripositive into Al. So first of all, in order to convert Al tripositive in Al, 3 electrons are required here. So the reaction is going to be Al tripositive plus 3 electrons, then gets converted into Al. Perfect. So, my dear students, if you look at this particular reaction, for the reduction of 1 mole Al tripositive, for the reduction of 1 mole Al tripositive, how many moles of electrons are required? 3 moles of electrons are required. For the reduction of 1 mole of Al tripositive, 3 moles of electrons are required. The charge present on 1 mole electron, is equal to 1 farad. So the charge present on 3 moles of electron will be 3 farad. 3 farad means 3 into 96500 coulombs. Perfect. So I would say the charge required for the reduction of 1 mole of Al positive. If the answer is in farads, then the answer is 3 farad. If the answer is in coulombs, then the answer is going to be 3 into 96500 coulombs. Okay, perfect. My dear students, look at the second one. This was the first question. Look at the second one. Here you want to convert 1 mole of copper dye positive into copper. So it's simple. So you want to convert copper dye positive into copper. So it has to gain 2 electrons, then get converted into copper. So if you look at this particular reaction, in order to reduce 1 mole of copper dye positive, how many moles of electrons are required? 2 moles of electrons are required. 2 mole electron means 2 farad. 2 farad means 2 into 96500 coulombs. Right? Perfect. Similarly, you can check this out, this one as well. So it's going to be, this is plus 7. So plus 7 to plus 2. Right? So 5 moles of electrons are required. Plus 7 to plus 2, 5 moles of electrons are required. So the answer of this question is going to be 5 farad. Right? So these sort of questions are frequently asked. These sort of questions are frequently asked. Okay? Moving on to one more question. Okay, these are two similar sort of questions, but I'll just solve one of it. Second is going to be your homework. Let me solve the first question. How much electricity in terms of farads is required to produce 20 grams of calcium from molten CaCl2? So when we do the electrolysis of molten CaCl2, what would be the reaction at cathode? At cathode, you know, reduction takes place. Reduction means gain of electrons. So Ca dye positive ions in the solution will go to cathode, will take 2 electrons from cathode and will get deposited at cathode in the form of calcium. Right? Yes? Fahim, I think you have not seen the title of the session. That was class 12th physical chemistry. That was not class 11th. Class 11th physical chemistry we are going to do in upcoming days. Okay? I hope I'm clear. That was class 12th physical chemistry. And in class 12th physical chemistry, there are only 3 chapters. Solution, kinetics and electrochemistry, which I covered yesterday. Okay, now look at this particular question, guys. First thing. How much electricity is required in terms of farads to produce 20 grams of calcium? From molten CaCl2. So first of all, when we do the electrolysis of molten CaCl2, this is going to be the reaction. And I would say at cathode, calcium is being deposited. What mass of calcium is being deposited? 20 grams. So can I say mass of calcium deposited as per Faraday's first law should be equal. Equivalent mass of calcium multiplied by I multiplied by T divided by 96500. Right? So mass of calcium deposited is how much? 20 grams. Equivalent mass of calcium would be molar mass of calcium divided by n factor of calcium. What is the n factor of calcium? Check it out. It's going to be 2 divided by 1. 2 divided by 1. That's 2. Right? Into 96500. This I into T is nothing but Q. Right? You can just solve it. So this is going to be 1. This is going to be 2. This 2 got cancelled. So Q comes out to be 96500 coulombs. This is the charge required such that 20 grams of calcium would be deposited at the cathode. Right? If the charge is in coulomb, then this is going to be the answer. If the charge is in farad, you know 96500 coulomb means 1 farad. Yeah? Done and dusted. Moving on to the next one. See, this is the similar type of the question. I believe you can solve this sort of a question on your own. Similar type of the question. Right? So I'm not repeating the patterns here. One pattern I showed you. This is something which you can do on your own. Okay? Tell me the answer of this particular question, guys. Look at it carefully. Look at it carefully. Look at it carefully. Done? Done. What do we have to calculate? Increasing order of reducing power. Yesterday, if you remember, reducing power is what? It's directly proportional to SOP. Simple. It is directly proportional to SOP, right? See, reducing power is directly proportional to SOP. So first of all, I have to check what is given to me. See, K positive to K. So plus 1 to 0. Decrease in the oxidation state means reduction. So this is SRP. Right? Plus 1 to 0, decrease in the oxidation state, reduction, so it's SRP. Plus 2 to 0, decrease in the oxidation state, so this again SRP. Plus 2 to 0, decrease in the oxidation state, this again SRP. And this again SRP. So I'm giving you the SRP values. What do I need? I need SOP values. I need SOP values. So what do we do? What do we do? I need SOP values. Now, I just need to revert the sign. So, if you talk about potassium, what is the SOP of potassium? SOP of potassium will be plus 2.93, right? SOP of silver will be how much? It will be minus 0.80 volt. SOP of mercury will be how much? It will be minus 0.79 volt. SOP of magnesium will be how much? It will be, change the sign, so plus 2.37 volt, right? And SOP of chromium would be, change the sign, plus 0.74 volt. So more the SOP, more the reducing power. Now, which one is showing maximum SOP here? What is the maximum value of SOP here? This is the maximum value of SOP, right? 2.93. 2.93 plus. So potassium will have the maximum reducing power. So potassium will have the maximum reducing power, followed by what? Followed by your magnesium. Followed by your magnesium. After magnesium, you are going to prioritize your chromium, right? Then comes your mercury, and then comes your silver. This is going to be the order of the reducing power. So simple, reducing power is directly proportional to SOP. That's it. Okay. Moving on to the next question, guys. Moving on to the next question. Look at the question carefully. Look at the question carefully. Look at the question carefully, guys. Every one of you. Every one of you, this is a simple question, and I believe you can solve this particular question. Well, molarity of the solution is given to me as 0.2. Conductivity kappa is also given to me as 0.0248 Simon centimeter inverse. What do I just need? I just need molar conductivity, right? And let me tell you, the units will be specified in the question. I need to calculate molar conductance in Simon centimeter square per mole. And if you remember the formula, it's again the direct formula based question. Lambda molar conductance is equal to kappa multiplied by 1000 divided by molarity. Kappa is given to me, molarity is given to me, put the values, get the value of lambda m. Simple. Simple, people. Zainab, don't take the screenshot. Screenshot मत लो, आपको ये PDF Telegram में मिल जाएगी. Don't worry. ठीक है, अभी आप try करो. Just try it now, right now. ठीक है, अभी आप rough पे try करो. That's it. There is no need to take any sort of screenshot because you'll be getting it anyways. Look at this particular question, guys. Looks a huge question. Looks a huge question. Looks a huge question. Three electrolytic cells A, B, C containing solutions of zinc sulfate, AgNO3 and copper sulfate respectively are connected in series. A current of 1.5 amperes was passed through them until 1.45 grams of silver was deposited at the cathode of cell B. How long did the current flow? What mass of copper and zinc were deposited? This is the question. Yeah? Let's see how to deal with this. First of all, you are given with three electrolytic cells. Let's say this is one, this is second one, and this is third one. Perfect. In the first one, what are we keeping? We are keeping zinc sulfate. In the second one, what are we keeping? We are keeping AgNO3. And in the third one, what are we keeping? We are keeping copper sulfate. We are keeping copper sulfate. Perfect. These are the respective electrodes. These are the respective electrodes. And you have connected these electrodes. You have connected these electrodes. Again with the external battery. Again with the external battery. Okay. Again with the external battery. Now, my dear students, as per the question is concerned, let's say zinc is deposited here. Let's say silver is deposited here. And over here, copper is deposited. Perfect. Something given in the question itself. And you should be knowing already. This is zinc sulfate. So zinc dye positive would have gone to cathode and undergone reduction. Perfect. So zinc solid would have deposited here. Silver solid would have deposited here. Copper solid would have deposited here. Now, as per the question is concerned, in the cathode of the cell B, how many grams of silver are being deposited? As per the question, it's mentioned that the mass of silver deposited is equal to how much? The mass of silver deposited is equal to 1.45 grams. Mass of silver deposited is equal to 1.45 grams. How much current is going into the solution? That's something I think we need to calculate, or is that given? The current of 1.5 amperes. Current of 1.5 amperes is going in all the solutions. Why? Because these solutions are in series, and in series connection current goes the same. In series connection, current is same always, right? Now, how do we solve the equation? Look at this particular cell, guys. On the cathode, silver is being deposited. If I use Faraday's first law for this particular cell, if I use Faraday's first law in this particular cell, what do? I'll write simply mass of silver deposited has to be equaled equivalent mass of silver multiplied by I multiplied by T divided by 96500. Right? This is something which I'll write. This is something which I'll write. Now, if you look carefully, see, zinc is getting deposited here. So what should be the reaction for zinc to get deposited? Zinc dye positive would have gained 2 electrons, got converted into zinc solid. That's why your zinc is deposited here. Over here, silver is being deposited. That means Ag positive in the solution would have accepted 1 electron, got converted into Ag solid. And here you can see copper is being deposited. That means copper dye positive would have gained 2 electrons and got converted into copper solid. These are the 3 reactions. Perfect. Now, equivalent mass of silver. Equivalent mass of silver. How much is that? Or let me write it completely. Mass of silver deposited, as per the question, is 1.45 grams, is equal to equivalent mass of silver. That is molar mass of silver, 108, divided by n factor of silver. So what is the n factor of silver? 1 divided by 1. That's 1 only. Multiplied by 96500. Multiplied by current is 1.5 amperes. Multiplied by T. So from this particular equation, if you do the cross multiple stuff, can't you calculate T from here? And as far as I remember, the value comes out to be 482.5 seconds. 482.5 seconds. So current of 1.5 amperes should pass through the solutions for 482.5 seconds. Then only 1.45 grams of silver will be deposited here. Do you understand? Do you understand? This is the first question. What is the second question here? How long, what mass of copper and zinc was deposited? What mass of copper and zinc was deposited here? What mass of copper and zinc was deposited here? So you can use Faraday's second law. Faraday's second law says that the gram equivalence of copper deposited here will be equal to gram equivalence of silver deposited, will be equal to gram equivalence of zinc deposited. So you can just write one thing, gram equivalence of copper deposited should be equal to gram equivalence of, for example, silver deposited, right? Okay. Gram equivalence of this deposited should be equal to gram equivalence of this. And gram equivalence of copper means mass of copper deposited divided by equivalent mass of copper is equal to gram equivalence of silver means mass of silver deposited divided by equivalent mass of silver. Now, my dear students, what do we need? We just need this particular term. Perfect. Mass of silver deposited, you know. Equivalent mass of silver will be molar mass of silver divided by n factor, right? You know it. Equivalent mass of copper will be molar mass of copper, which is 63.5 divided by its n factor. N factor of copper is 2 divided by 1, that's 2. So you can calculate the mass of copper deposited. Similarly, you can calculate the mass of zinc deposited as well. Right? Perfect. Right, people? I believe I'm clear to everyone. Yes? Is it clear to everyone? So gram equivalence deposited on every electrode will be the same. Gram equivalence of this will be equal to gram equivalence of this will be equal to gram equivalence of this. Nothing else. Perfect. Now, first of all, I'm going to equate their gram equivalence like you saw here. Perfect. Then I'll be equating the gram equivalence of these two. I'll get the mass of zinc deposited as well. Can you tell me the answer of this one? Well, this is a simple one. Quickly tell me the answer of this one. What's the answer of this question? Quickly. Everyone. Guys, you should not be taking this much of time to solve this one. Copper here is in 0 oxidation state, silver is in +1. Copper here is in +2, silver 0. So 0 to +2, increase. Increase means oxidation. Oxidation takes place at anode. So this is your anode. If this is anode, that means this is cathode. Perfect. So these are the two lines which represent the salt bridge. On the left side of the salt bridge, what do we write? Anode. At anode, copper solid is getting converted into copper dye positive. So copper solid is getting converted into copper dye positive aqueous. Now at cathode, reduction takes place. Reduction of Ag positive. Ag positive is getting converted into Ag. So I'll write Ag positive aqueous getting converted into what? Getting converted into Ag solid. Right? Do you see any option like that? Do you see any option like that? Yeah, first one only. So first one is the correct one. Yes? I've already given the solution chapter in the video format. Just look at the comments of the yesterday's session. You'll get it. Look at this question, guys. Look at this particular question. Look at this particular question. Look at this particular question. Quickly, everyone in the chats. See guys, you have to check a lot of things basically, right? You have to check a lot of things. If you look at the cell, there's the salt bridge. On the left side, you write anode. At anode, oxidation takes place. Copper is getting converted into copper dye positive. So I would say copper solid is getting converted into copper dye positive aqueous. And with that, you'll be writing 2 electrons. This is the reaction at anode. Similarly, reaction at cathode. Ag positive is getting converted into Ag. So I would say Ag positive aqueous would be gaining 1 electron and getting converted into Ag solid. Now tell me one thing, are the electrons balanced in both the reactions? No, I'm supposed to balance the electrons. So multiply with 2. If you multiply with 2, this becomes 2 times, this becomes 2 times. Now when you add these two, the net reaction becomes copper solid plus 2 times Ag positive aqueous, 2 times Ag positive aqueous, it gives copper dye positive aqueous plus 2 times Ag solid. This is my net reaction. This is my net reaction. How many moles of electrons got exchanged? 2. Now people, let's check the options. So first of all, the first option says copper is a reducing agent. See, copper is undergoing oxidation here. 0 to plus 2. 0 to plus 2 means increase in the oxidation state. Increase in the oxidation state means oxidation. And the one that undergoes oxidation, that's what you call as a reducing agent. The one that undergoes oxidation is called as a reducing agent. So this one is correct. Overall cell reaction is this one. Look at the cell reaction. Is it the same? Copper solid, this gives this plus this. Yes, this is also correct. Copper is cathode. Is copper cathode or anode? Copper is on the left side of the solid, so it's anode. It's not cathode. So this is wrong. Ag is anode. Is Ag anode or cathode? Ag is cathode. So this is also wrong. So the correct answer is going to be 1 and 2. 1 and 2, 1 and 2. That means option D. Yes? Right? Now, moving ahead to one more. Tell me the answer of this particular question. Priyadarshini, I told you tomorrow I am taking the session in the Dream Crash Course batch. Okay? Quickly, guys, what do you think is the answer of this one? We have to check which of the following is the strongest oxidizing agent. Strongest oxidizing agent. Directly proportional to SRP. Directly proportional to SRP, right? Oxidizing power, oxidizing agent, directly proportional to what? Directly proportional to SRP. Am I given with SRP? Check it out. Li positive to Li. So plus 1 to 0. Decrease in the oxidation state. Reduction. So this is SRP. Plus 2 to 0. Decrease in the oxidation state. SRP. Plus 1 to 0. Decrease in the oxidation state. SRP. So all these are SRP values. So which is the maximum SRP? Where do you see the maximum SRP? This is minus 3.03, minus 2.74, minus 2.71, minus 2. This is maximum. This is maximum among all. Right? This is maximum among all. So this is maximum for what? It is maximum for your magnesium dye positive. So the answer is going to be Mg dye positive. Correct? Yes? I hope this is clear. Give me the answer of this particular question quick. Give me the answer of this question quick. We have got 3 metals X, Y and Z. Their standard electrode potentials. So again, standard electrode potential is given. They have not mentioned whether standard oxidation potential or standard reduction potential. So if it is mentioned as standard electrode potentials, you'll be considering them as standard reduction potentials. So technically SRP values are given. SRP values are given. And what are the SRP values? If you look carefully, SRP value of X, Y and Z. SRP value of X is minus 1.2 volt. This is 0.5 volt and this is minus 3 volt. Right? The reducing power. You know, reducing power is directly proportional to SOP. Reducing power is directly proportional to SOP. But these are SRP values. So convert them into SOP values. Convert them into SOP values. This will be plus 1.2. This will be minus 0.5. This will be plus 3. Now, which one has got maximum SOP? This Z has got maximum SOP. Maximum SOP means maximum reducing power. So Z has got maximum reducing power. Z has got maximum reducing power. So it's option C. Right? In only one option, there is Z having maximum this. Tell me the answer of this particular question. I hope the question is visible to you. Carefully look at the question and try solving it. Look at the question carefully and try solving it, people. Everyone. Everyone. Quickly. Done? Strongest reducing agent, right? Again, reducing agent. Reducing agent means reducing agent. Directly proportional to SOP. Directly proportional to SOP. What are these values given? Since in every reaction, reduction is happening. Reduction means these are SRP values. These are your SRP values. So I want SOP values. I want SOP values. What are going to be SOP values? This is minus 0.762. So plus 0.762. Minus 0.74 plus 0.74. This is already 0. This is 0 again. Plus 0.77 minus 0.77. So where do you see SOP maximum? SOP is maximum where? Here SOP is maximum. Right? Here SOP is maximum. So zinc has got maximum SOP. Maximum SOP means strongest reducing agent. Guys, this chat should not stop. Chats should not stop. Okay? Chats should not stop. You should continuously write the answers. If it is wrong, also does not matter. Similar sort of question. Check it out. Similar sort of question. We are given with 4 reactions. The reducing power. I hope this sort of equation you can do. I'm not going to solve it. I'm waiting for your just answers. I'm just waiting for your answers. Reducing power. Directly proportional to SOP. What is given? SRPs are given. So convert them into SOP. Convert them into SOP. So that will become plus 2.87, right? That's maximum angol. So calcium will have maximum reducing power. After calcium, it's going to be plus 2.36. Then it's going to be magnesium, right? So it's done. Option B. Yeah? Sir, आप कहाँ से हो? मैं कश्मीर से हूँ. श्रीनगर से. Right? Right, people? Are we done with this? Yes, we are done with this. Check this one out. Check this one out quick. Check this one out. We are supposed to calculate EMF. EMF means, so technically we are supposed to calculate E naught cell. That is nothing but E naught cathode minus E naught anode. E naught cathode minus E naught anode. Now, look at zinc. 0 to plus 2. Increase in the oxidation state. Oxidation. So zinc is working like the... Zinc is undergoing oxidation. So this is your anode and this is your cathode. What do I need? I need SRP of cathode first. SRP of cathode. Cathode is iron, right? But this is SOP of iron. Because loss of electrons is happening. This is SOP of iron. I need SRP of iron, right? Minus SRP of anode. SRP of cathode minus SRP of anode. Anode is zinc. This is SOP of zinc. I need SRP of zinc. So minus 0.76. The value comes out to be 0.35 volts. Right? So option B. Correct? Option B. Look at this one. Look at this one. Look at this one, guys. Quickly. Look at this one. This you should be easily solving, guys. I mean, you should not take a lot of time to solve this question. If you look at the question, standard electrode potentials. So Sn plus 4 to Sn di positive. Plus 4 to plus 2, decrease. Decrease means reduction, right? Decrease means reduction. So its SRP is given. SRP is given to me as 0.15 volts. Similarly, second one is your Cr tripositive. Cr tripositive gives chromium. Plus 3 to 0, decrease. Decrease means reduction. So it's given to me as minus 0.74 volts, right? So this also SRP. Perfect. Now, so basically you are given two electrodes. You are given with two electrodes, right? Since you are given with two electrodes, you are connecting them externally as well as internally. So you'll be getting a complete cell. How do I calculate E naught of that particular cell? E naught cell is nothing but E naught cathode minus E naught anode. E naught anode. Now SRP values are given. Which one has more SRP? This is the more value of SRP. More the value of SRP. That means more value of SRP means more is the tendency to undergo reduction. And reduction takes place at cathode. So this is your cathode. This is automatically your anode, right? So E naught cathode. SRP of cathode is 0.15 minus SRP of anode will be minus 0.74, right? So the value will be 0.89 volts. Is any option like that? Option B. What answer you gave? Option B. Correct. Good one. Good one. Can we give this question a try? Calculate the oxidation potential of the following half cell. I'm giving you the half cell. I need to calculate its oxidation potential. I need to calculate its oxidation potential. See, the oxidation state of iron here is 0. Here it's plus 2. In order to calculate oxidation potential, oxidation means oxidation takes place at anode, right? Oxidation takes place at anode. In order to calculate the oxidation potential, I'll make sure the half cell, the electrode behaves like the anode. And when the electrode behaves like the anode, oxidation will happen. Iron will go to Fe di positive. So the reaction is going to be Fe solid gives Fe di positive aqueous plus 2 electrons. This is the reaction which will be taking place when this particular half cell will be behaving like anode. When this particular electrode will be behaving like anode, right? What is the value of N here? N value here is 2. If I ask you the QC value, QC is going to be concentration of Fe di positive raised power 1 divided by, this is solid, nothing to do with that. What is the concentration of Fe di positive? It is 0.1 molar, which means 10 raised power minus 1. So N I got QC. And I got QC. What do I need? I need oxidation potential. So use the Nernst equation. EOX is equal to E naught OX minus 0.0591 divided by N log of QC. What is E naught OX? E naught OX means SOP. SOP. What are we given with? Plus 2 to 0. Decrease, reduction. Decrease in the oxidation state means reduction. So this is SRP. What do I need? I need SOP. So change the sign. It's plus 0.44 minus 0.0591. What is the value of N? N value here is 2. N value here is 2. Log of QC. QC is 10 raised power minus 1. So it comes out to be plus 0.44 minus 0.0591 divided by 2. Log of M raised power N is N log M. So minus 1 comes to the front. Log 10 is 1. So solve this. The answer is going to be in volt. Yes. So I think this is the nearest answer which I feel is going to be 1. Right? Yes. Perfect. Moving on. Moving on. Look at this question. E naught cell is given as 4 volts. We have to calculate EMF. Again, Nernst equation. Again, Nernst equation. Again, Nernst equation, guys. Again, Nernst equation. So first of all, in order to write the Nernst equation, I'll write the reaction at anode. Since this is the anode, your M solid is getting converted into what? M di positive aqueous, whose concentration is 10 raised power minus 2 molar plus 2 electrons. This is the reaction at anode. What is the reaction at cathode? M di positive gives M. So reaction at cathode will be M di positive aqueous, whose concentration is 10 raised power minus 4 molar. It will be gaining 2 electrons and then getting converted into M solid. So when you add these two reactions, M and M gets cancelled. So this is M di positive aqueous, whose concentration I'm keeping as 10 raised power minus 4 molar. It gives M di positive aqueous, whose concentration I'm keeping as 10 raised power minus 2 molar. Now, can I calculate QC? QC is going to be concentration of this, that is 10 raised power minus 2, divided by this concentration, 10 raised power minus 4. The value comes out to be 10 raised power 2. So this is QC. N value here is how much? N value here is 2. So use the Nernst equation, which you already know. E cell is equal to E naught cell is given to me how much? 4 volt minus 0.0591, n value is 2, log of QC. QC is 10 raised power 2. So it's going to be 4 minus 0.0591 divided by 2, log of m raised power n is n log m. So 2 comes to the front, so 2 gets cancelled. So 4 minus 0.0591. So 3 point something will be the answer. Yes? Perfectly done. I'm just using the Nernst equation and killing the equation. That's it. That's it, guys. By the way, those questions which are repeated patterns I'm not showing here. For example, this was one of the question, right? If I see the similar sort of the question in the slides, I'm keeping it as such. Do give that question a try at home when you receive the slides, when you receive it in the Telegram channel, okay? Similar patterns of the questions I'm not repeating here. Check this out quick. Check this out quick, people. Everyone. Check this out. Calculate E naught cell. Equilibrium constant is given. E naught cell, equilibrium constant. One thing is coming into my mind. What is that? One thing is coming into my mind. What is that? That is Nernst equation at equilibrium. And how do I write Nernst equation at equilibrium? E naught cell is equal to 0.0591 divided by n. It's a log of equilibrium constant KEQ, right? Now, what do I have to calculate? I have to calculate E naught cell. This is going to be equal to 0.0591. What is the value of n? N value for the reaction, when you check it, it's 2. Log of equilibrium constant is 10 raised power 6. So, bus, the equation is done. 0.0591 divided by 2. Log of m raised power n is n log m. So, 6 comes to the front. Log 10 is 1. Solve this. You're sorted. You're done. Yeah? Perfect. All right. All right. Check this one out quick. Check this one out quick, guys. Sir Rajbagh कर रही हूँ बस 2 है सर Rajbagh बस 2 Rajbagh you will be copying all these questions in the notebook once you receive the PDF of this session. Standard Gibbs free energy for the given cell. You have to calculate delta G naught. Delta G naught is what? Minus NF E naught cell. Correct? Right? Is E naught cell given? Yes, E naught cell is given. First of all, what is the value of N? Zinc gives zinc dye positive, so N value is 2. Faraday is constant, 96500. E naught cell is given. How much? 2 volt. The answer right now will be in joules. Why? Because I used all the parameters as per SI system. But the answer they are asking in kilojoules. So divide with 1000. The answer is now going to be in kilojoules. Solve it, get the answer. That's it. Yes? Look at this question. Look at this question, guys, quickly. Quickly, people, quickly, everyone. Done? For the reduction of silver ions with copper metal. So, for the reduction of silver ions with copper metal. So, basically, silver ions are undergoing reduction. Silver ions are undergoing reduction. So the reaction is going to be Ag positive plus 1 electron gives Ag. For the reduction of silver ions with copper metal, if silver is undergoing reduction, that means copper will be undergoing oxidation. Copper will be undergoing oxidation. Oxidation takes place at anode. So this, for example, your anode. This is your cathode, because at cathode reduction takes place. Now, are the electrons balanced? No. Multiply this reaction with 2. This becomes 2 times. This becomes 2 times. This becomes 2 times. Add both the reactions. So net reaction is going to be 2 times Ag positive plus copper gives what? Copper dye positive plus 2 times Ag. This is the net reaction, right? What is the N value? N value here is 2. What do I need? I need delta G naught. I got N value. Is E naught given? The standard potential. Yes, E naught is also given. Everything is given. So what do I have to calculate? Delta G naught. Delta G naught is equal to minus NF E naught. What is the value of N? N value is 2. Faraday's constant. 96500. What is E naught? E naught is given to me as 0.46. The answer right now is going to be in joules. So divide. Okay, I need the answer in joules only, I think. Joules or kilojoules, whatever. So divide it with 1000. The answer is going to be in kilojoules. Right? Simple basic question again. Check this one out. Check this one out, guys. Quick. Quickly. Check this one out. What do we have to calculate? Standard Gibbs free energy change, delta G naught. And you know delta G naught is nothing but that's equal to minus NF E naught cell. See, from the reaction itself, we can calculate N. This is copper to copper dye positive. So N is 2. N is 2. We know that. Faraday's constant we know. Now, E naught cell is not given. So let's calculate E naught cell. E naught cell will be equal to E naught cathode minus E naught anode. E naught cathode minus E naught anode. This is SRP of cathode. Since cathode is your tin hair. Cathode is your tin hair, right? Cathode is your tin hair. I think the values in the questions are wrong. The values in the question are wrong, guys. Why is that? Why do I feel so? 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 Can you tell me that? Why do I feel the values are wrong? See, copper is undergoing oxidation, 0 to plus 2. 0 to plus 2. It is undergoing oxidation. So this is supposed to be anode. Copper is supposed to be anode here. And this tin is supposed to be cathode. If tin is supposed to be cathode, that means SRP of tin should be more. But SRP of tin is less here than copper. Okay? So this is a gadbad question. Don't just write A, B, C, D. Why are you giving me the answer? I'm telling you there is some gadbad in the question. But still writing A, B, C, D. Did you understand what I said? Did you understand what I said? So basically, copper is undergoing oxidation. So copper should behave like anode, right? And tin should behave like cathode. If tin has to behave like cathode, that means at cathode reduction takes place. So SRP of tin should be more. But here SRP of tin is less, right? It's a gadbad question. I'm keeping it as such. Okay? Okay, what about this one? What about this one? If the E naught cell has a negative value, E naught cell has negative value, okay? All right. E naught cell is negative. So if E naught cell is negative, delta G naught is minus NF E naught cell, right? If E naught cell is negative, negative makes it positive. So delta G naught is supposed to be positive. Delta G naught is supposed to be positive. So delta G naught is supposed to be positive. Delta G naught is supposed to be positive. Now, delta G naught in terms of equilibrium constant. You know the formula? Delta G naught is equal to minus RT ln of KEQ. So delta G is supposed to be positive. Delta G is supposed to be positive. When is that possible? Delta G naught is supposed to be positive. That is possible only when this particular term will be negative. When this particular term will be negative, then only negative will come out to be positive. When is the log of x negative? When is log of x negative? When x is less than 1. So when is the log of KEQ negative? When KEQ is less than 1. So KEQ should be less than 1. Got it? This is how you deal with such kind of the questions. Sir, in the previous question, SOP of copper is given. No, I think SRP of copper was given. Where did that question go? It is not SOP. It's plus 2 to 0. Plus 2 to 0 means decrease. Decrease means reduction. So it's SRP. It's not SOP. It's not SOP. Plus 2 to 0. Decrease in the oxidation state, which means reduction. So this SRP, not SOP. What are you saying? Okay, moving ahead. Moving ahead. Look at this question. The electrode potentials of this and this are given. Calculate the value. See, the question is not properly visible. Let me make it clear to you. The question says we are given the reaction copper dye positive plus electron gives copper positive. This is one reaction. Its E value is given to us as 0.15 volt. Second reaction, copper positive plus electron gives copper. Its E2 value is given to us as 0.5 volt. We have to calculate E naught of copper dye positive gives copper. That means copper dye positive plus 2 electrons gives copper. Its E3 value is to be calculated. Do you remember in the yesterday session, I've shown you this sort of a question? Do you remember? Do you remember, people? Do you remember? So first of all, the reaction whose E value is to be calculated. The reaction whose E value is to be calculated. You are supposed to make this reaction out of the reactions whose E value is given. Now, how do we make this reaction? You have got 2 electrons here. So these two are supposed to be added. When you add first and second, copper positive gets cancelled. Copper dye positive plus 2 electrons gives copper. So how do you make third reaction? I can say third reaction I'm able to make when I'm adding first and second. Simple. Now, instead of third, I'll write delta G3. Instead of 1, I'll write delta G1. Instead of 2, I'll write delta G2. Now, you know, delta G3 will be minus N3 FE3 is equal to minus N1 FE1 minus N2 FE2. Correct? So, F everywhere cancels out. Right? So, E3 value will come out to be equal to N1 E1 plus N2 E2 divided by N3. Right? E1, E2 are given to me in the question. E1, E2 are given. Now, what is N1? What is N2? What is N3? This is N1, 1. N2 is also 1. N3 is 2. N1 is 1. N2 is 1. N3 is 2. So, you have all the values. N1, N2, N3. E1, E2. Put the values and get the answer. That's it. Okay? Look at this particular question. Look at this particular question, guys. Look at this particular question. Well, I can see the options in terms of RT. I can see the options in terms of RT. So that means if we are using Nernst equation, we have to use which Nernst equation? The actual one. E cell is equal to E naught cell minus 2.303 RT divided by NF log of QC. That equation we have to use here. Yeah. See, guys, first of all, you are given with the cell, right? You are given with the cell. Let me write the net cell reaction directly. Net cell reaction is going to be like this. Zinc solid plus copper dye positive aqueous. It gives zinc dye positive aqueous plus copper solid. Right? Because it's a Daniell cell given. Correct? It's a Daniell cell given. And this is the net reaction in the Daniell cell. Anyways, you can write it also if you want. Reaction at anode, reaction at cathode, balance the electrons, then you'll be getting this particular one. Right? Now, people, if I write the QC expression, QC is going to be concentration of zinc dye positive raised power 1 divided by concentration of copper dye positive raised power 1. This is solid, nothing to do with this. This is solid, nothing to do with this. Now, the question says the concentration of zinc dye positive. The question says the concentration of zinc dye positive is 10 times the concentration of Cu dye positive. 10 times the concentration of Cu dye positive. So, it means that concentration of Zn dye positive divided by concentration of Cu dye positive is equal to 10, right? So concentration of Zn dye positive divided by concentration of Cu dye positive is equal to 10. This is something that's given to me basically, right? Now, if I use the Nernst equation says that E cell is equal to E naught cell. How much is E naught cell? 1.1 volt minus 2.303 RT divided by NF. N value for the reaction is 2, so it's 2F. Log of QC. QC is 10. Log 10 is 1. So this is your basically E cell. This is basically your E cell. What do we need? We need to calculate delta G. How do we calculate delta G? Delta G is equal to minus NF E cell. So delta G would be equal to minus N value is 2. F I'm writing as such, right? And E cell value we have calculated. E cell is equal to 1.1 minus 2.303 RT divided by 2F. Okay? So it's going to be delta G is equal to. This is going to be 2F into 1.1. That's going to be minus 2.2F. Correct? Minus comes out to be plus. 2F cancels out. So it's going to be 2.303 RT. Do you see any option like this? Is there any option like this? Minus 2.2F. Minus 2.2F plus 2.303 RT. Yes, it's option C. Understood? Understood, guys? So how I got this question solved? I wrote the Nernst equation in terms of this form, 2.303 RT form, right? After that, I used delta G equation. Put the values, got the answer. That's it. That's it, okay? Can you solve this one? Can you solve this particular question? Calculate the oxidation potential of the following half cell. So technically, if you see, this is your hydrogen electrode. We have to calculate its oxidation potential. Oxidation happens at anode. So I'll make sure that this electrode behaves like anode. If this electrode behaves like anode, what's going to happen? Oxidation. And when hydrogen electrode behaves like anode, what is the reaction? Reaction I gave you yesterday, H2 gas gives 2 times H positive aqueous plus 2 electrons. This is the reaction when hydrogen electrode undergoes oxidation, right? When hydrogen electrode behaves like anode. Now, what is the value of N here? N value is 2. If you want to write the QC expression, it's concentration of H positive raised power 2 divided by partial pressure of H2. Now, I think everything is given. What is the concentration of H positive? Concentration of H positive is 0.1. 0.1 means 10 raised power minus 1. So it's 10 raised power minus 1 ka square. What is the partial pressure of H2? Partial pressure of H2 is 10, right? So the value comes out to be 10 raised power minus 3. So this is QC. You got the N value. What do I need? I need oxidation potential. I can write Nernst equation as EOX is equal to E naught OX minus 0.0591 divided by N and its log of QC. Correct? Now, E naught OX means standard oxidation potential, and standard oxidation potential of hydrogen electrode is 0. You know that already. So EOX is equal to minus 0.0591 divided by N value is 2 log of QC. QC is 10 raised power minus 3. Now just the matter of calculation, nothing else. So minus 0.0591 divided by 2 log of M raised power N, which is N log M. So minus 3 comes to the front, log 10 is 1, right? Solve it, get the answer in volt. Done? Okay, guys, this sort of a question, again, you should be in a position to solve from now onwards. Look at this question. Look at this question carefully. Read the question carefully. That's what I want from you first of all. Read the question carefully first. Guys, this is something which you should be quickly solving. It should not take a lot of time. Okay, see how do I deal with such kind of a question. A zinc rod is dipped in a 0.1 molar solution of its salt at 25 degrees centigrade. Assume the electrolyte is 20% dissociated. Calculate the electrode potential. Electrode potential means the reduction potential. Calculate the electrode potential of the half cell. See how do I solve this question. So basically, as per the question, there is a container and the container contains the salt of zinc. In this container, you have got salt of zinc. Salt of zinc means, for example, zinc sulfate. How zinc sulfate undergoes dissociation? Zinc dye positive plus SO4 dye negative. And in this particular container, we have got zinc rod as well. This is the zinc rod. Zinc rod is placed in a solution containing the zinc ions. So this is basically your zinc electrode. This is basically your zinc electrode. Now the question says, calculate the electrode potential when 20% zinc sulfate is dissociated. When 20% zinc sulfate is dissociated. So basically, at time t is equal to 0, what is the initial concentration of zinc sulfate? It's given to be as 0.1 molar, right? So this would be 0, this would be 0. Now, we have to calculate the electrode potential. We have to calculate the reduction potential basically. We have to calculate the reduction potential of the electrode when 20% of electrolyte got dissociated. When 20% of the electrolyte got dissociated. What is 20%? What is meant by 20%? 20% means 20% zinc sulfate has got converted into its ions. 20% zinc sulfate has got converted into ions. So what is 20% of 0.1? What is 20% of 0.1? It comes out to be 0.02. So out of 0.1 moles of zinc sulfate, how much zinc sulfate got converted into product? 0.02. So I'll be left with 0.1 minus 0.02, right? Now, 1 mole gives 1 mole, 0.02 would have given 0.02 molar. This would be also 0.02 molar. So basically, when 20% zinc sulfate got dissociated, at that point of time, the concentration of zinc dye positive in the solution is 0.02 molar. Concentration of SO4 dye negative is also 0.02 molar. Point number one. Point number one. Point number two. What do I need? What do I need? I need to calculate the reduction potential of the zinc electrode. Since in order to calculate reduction potential, I'll make sure this electrode behaves like the cathode. And when zinc electrode behaves like cathode, reduction is going to happen. So zinc dye positives in the solution, they are going to collide with the rod. Take 2 electrons from the rod, get converted to zinc solid, right? N value is 2. Now QC. QC is going to be 1 divided by concentration of zinc dye positive. So it's 1 divided by. What is the concentration of zinc dye positive when 20% electrolyte is dissociated? 0.02. The value comes out to be 50. So QC is 50. What do I need? I need the reduction potential. So, reduction potential. E naught ERED is equal to E naught RED minus 0.0591 divided by N log of QC. Log of QC. What is E naught RED? This is SRP of zinc. SRP of zinc is given to me as minus 0.76 minus 0.0591. N value is already 2. Log of QC. QC value is equal to 50. Just a matter of calculation and you'll be getting the reduction potential. Got it, people? I hope you got this particular step. We were supposed to calculate the reduction potential of the electrode when 20% salt has dissociated. What does that mean? That means 20% of 0.1 is 0.02. That means I'm assuming when 20% salt is dissociated, out of 0.1 moles of zinc sulfate, 0.02 moles of it got converted into products. Yeah? I believe this sort of a question is done. I believe this sort of a question is done. Okay. This is something which all of you should remember. This is something which all of you should remember. I showed you this in the yesterday's session, as well as I had shared one page on Telegram group wherein the electrolysis of all the electrolytes was given. Tell me. Tell me, what is the answer? You are doing the electrolysis of aqueous copper sulfate. When electrolysis of aqueous copper sulfate takes place, what happens at cathode? At cathode, copper gets deposited. At an anode, O2 gets liberated, right? Guys, you should be remembering all this. Sir, log of 50. Log of 50 you can calculate like this. Log of 50 is log of 5 into 10. So log of m into n is basically log m plus log n. Now we can solve. This is log 10, 1. Log 5 means 0.69, right? So it is going to be 1 plus 0.69, 1.69 almost. Okay, this is the answer. Perfect. Okay. Tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this question. Done, guys? People are saying option B. Is that? Let's see. So basically, you want to convert MnO4 dinegative into MnO4 negative, right? You want to convert MnO4 dinegative into MnO4 negative. Now tell me one thing. What is the oxidation state of manganese here? Plus 6. Oxidation state of manganese here? Plus 7. So plus 6 to plus 7. Increase. Increase means oxidation. Loss of electrons. So plus 6 to plus 7 means 1 electron. Right? Perfect. Now, as if you look at this particular reaction, when 1 mole of MnO4 negative, when 1 mole of MnO4 dinegative undergoes oxidation, right? We get 1 mole of electrons. 1 mole of electron means 1 farad charge. For 1 mole MnO4 dinegative, 1 farad charge. Do we have 1 mole of MnO4 dinegative or 0.1? 0.1. So for 1 mole, it's 1 farad. So for 0.1 moles of MnO4 dinegative, it's going to be 0.1 farad. So it's going to be 0.1 into 96500. The value comes out to be 9650 coulombs. Is the answer? Option C. I'll give you the dinner break. Wait, even I'm not done with the dinner yet. We'll complete electrochemistry and I'll give you the dinner break, okay? It will not take more than 10 to 15 minutes to complete electrochemistry. There are some questions which are repeated here. That's why I'm leaving them. Okay, tell me the answer of this one. At least guys, everyone should solve. I mean, there is nothing to solve in this question. Just tell me this. Done? Faraday's second law is based on what? Equivalence. Gram equivalence deposited at every electrode. Gram equivalence deposited or liberated at every electrode will be the same. Okay. What about this one? What about this one? If same quantity of electricity is passed through the solution of copper sulfate and AgNO3 connected in series, the equivalents of copper and silver deposited are the same. Faraday's second law only. Equivalents deposited at liberated, every electrode will be the same. Again, the similar sort of question. Tell me the answer of this one. Tell me the answer of this one. Quick. Which of the following solutions will have highest molar conductance? Do you see CH3COH, 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 CH3COH? So it's weak electrolyte basically. So it's weak electrolyte, right? Weak electrolyte. You know, with dilution, when you do the dilution, molar conductance increases, right? Molar conductance increases with dilution, be it for strong electrolyte, be it for weak electrolyte. Dilution means increase in volume. Dilution means you are putting more solvent. That means volume increases. So basically, if I talk about concentration, concentration is number of moles divided by volume. So with dilution, volume increases, so concentration decreases. So you can say with the dilution, what happens to concentration? Concentration decreases and molar conductance increases, right? So wherever concentration is least, molar conductance will be maximum. So where is the concentration least? Concentration is least here. The molar conductance will be maximum here. Okay? This is the concept which we'll be using to solve this question. Simple. Okay. What do you think about this one? The resistance of one normal solution of acetic acid. Resistance is given. Resistance is given as 250 ohm. Normality of the solution is given as 1. Cell constant L by A is given as 1.15 centimeter inverse. What do I need? I need equivalent conductance. In Simon centimeter square per equivalent. Okay. I need equivalent conductance. Lambda EQ. Lambda EQ is equal to kappa multiplied with 1000 divided by normality. Right? Now normality is given. What do I need? I need kappa. How do I calculate kappa? There is a result. Kappa is equal to 1 by R into L by A. Right? So kappa will be equal to 1 by R. Kappa will be equal to 1 by R. R value is 250. L by A is called as cell constant, which is given to me as 1.15. So you got the value of kappa. If you got the value of kappa, put the value of kappa here. Normality is already given. So lambda EQ you will calculate. Again, the matter of calculation, nothing else. Yes? Again, the matter of calculation, nothing else. Even this sort of question I have shown you in the yesterday session. I hope you remember. I think this question we solved yesterday also. It's a simple one. Limiting molar conductance of Ca dye positive and Cl negatives are given. We need to calculate limiting molar conductance of CaCl2. So limiting molar conductance of CaCl2 will be how much? It will be lambda naught m of Ca dye positive plus 2 times lambda naught m of Cl negative. Because CaCl2 dissociates as Ca dye positive plus twice Cl negative. I hope you remember. Yeah? So this is given, this is given. Put the values, get the answer. That's it. Even this question was solved in the yesterday session, right? The answer of this question was 4%. I hope you remember. Yeah? Degree of dissociation. Okay. Well, I'm not repeating the similar types of the questions, okay? This question we have already solved, XYZ. All right. Even this question we have already solved a few minutes back. It is repeated here. Just a second. Even this question we already solved equilibrium constant of the reaction. Yes, it's already solved. 4 and 10 raised power 15. Its answer was. Okay, this question is not solved yet. What do you think about this one? What do you think about this one? For the cell involving one electron. Cell involving one electron means n value is 1. E naught is given as how much? E naught cell is given as 0.59 volt. What do I need? Equilibrium constant. If you want to calculate equilibrium constant, write the Lorentz equation at equilibrium. That is E naught cell is equal to 0.0591 divided by n. Then it's log of KEQ. Right? E naught cell is 0.59 is equal to 0.0591. N value is 1. Log of KEQ. Right? So this is 1. This is 10. So you got to know log of KEQ is equal to 10. Which means that KEQ is equal to NT log of 10. Which means that KEQ is equal to NT log of 10. And how do I calculate NT log of 10? Since there is no decimal, so it's going to be directly 10 raised power 10. It's going to be directly 10 raised power 10. If there was decimal, like 10.3 for example, if it was 10.3, how you would have solved the NT log? 10 plus 0.3. This 10 you would have written as 10 raised power 10. 0.3 was log of 2. So this was 2 into 10 raised power 10 then. But this is just 10 with no decimal, so directly 10 raised power 10. Right? Directly 10 raised power 10. So this is the answer of the question. Okay? Well, some questions are repeated here. So, okay, look at this one. Good one. This was asked last year in JEE Mains examination. Look at it. Consider the following reaction. Reaction is given. E cell is equal to E naught cell. Everything is given. pH is equal to X. Okay, pH is equal to X. So first of all, pH is equal to X. What does that mean? If pH is X, that means H positive concentration is 10 raised power minus 6. Number one. What do we have to calculate? We have to calculate this X only. Okay. Now, first of all, the reaction that's given to me, can I write its QC value? Yes. I can write its QC value. Start with the product. Concentration of Fe di positive. Raised power stoichiometric coefficient. Right? This water is in liquid state, nothing to do with that. Divided by solid, nothing to do with that. This is partial pressure of O2. Raised power stoichiometric coefficient 1. And this is concentration of H positive. Raised power stoichiometric coefficient 4. What is the concentration of Fe di positive? It is given. Is it given? 10 raised power minus 3. 10 raised power minus 3 ka square comes out to be 10 raised power minus 6. Partial pressure of O2 must be given as well. How much? Yes. 10 raised power minus 2. Concentration of H positive. Concentration of H positive. Just now I told you. 10 raised power minus 6. 10 raised power minus 6. Raised power what? Raised power 4. So this and this gets cancelled. It becomes 10 raised power minus 4 at the top divided by 10 raised power minus 4x. This is something I got till now. Now, in the question, if you look carefully, E cell is equal to E naught cell. First of all, if you write the expression for E cell is E cell is equal to E naught cell minus 0.0591 divided by N log of QC, right? This is the expression. Now the point is, in the question they are mentioning that E cell is equal to E naught cell. When can be E cell equal to E naught cell? That's only possible if this term is 0. That's only possible if this term becomes 0. When can be this term 0? See, if this term is 0, then E cell becomes equal to E naught cell. Now, when can be this term 0? This term can be 0 only if this particular term is 1. If this term is 1, then only log of 1 becomes 0. Then we get log of 1, and log of 1 is already 0. We know that. So basically, E cell can be only equal to E naught cell if this particular term is 0. This particular term can become 0 only if QC is equal to 1. Right? What is QC? QC is 10 raised power minus 4 divided by 10 raised power minus 4x. This has to be equal to 1. If you cross multiple, it means that 10 raised power minus 4 is equal to 10 raised power minus 4x. If you compare, this directly means x value has to be equal to what? X value has to be equal to 1. If you compare, x value has to be equal to 1. Right? This x I was supposed to calculate. Done and dusted, right? Perfect, guys? Perfectly done. This question we have solved. There are some questions which are repeated. Okay. There are some questions which are repeated, guys. So even this question we solved a few minutes back. Okay. Look at this one. Look at this one, guys. The question is, what should be the pressure of H2 required to make the potential? Potential means reduction potential. Potential means reduction potential of hydrogen electrode 0 in pure water. Pure water. What can I get out of pure water? See, pure water means pH has to be 7. If pH has to be 7, that means concentration of H positive should be, 10 raised power minus 7 molar. See, all these things should strike your mind as well. The way things are striking my mind by just looking at the question, they should strike your mind too. The question is, what should be the pressure of H2 so that reduction potential of hydrogen electrode becomes 0 in pure water? Right? Now, we have to make a reduction potential of hydrogen electrode 0. Reduction potential of hydrogen electrode we have to make 0. The point is, reduction takes place at cathode. So that means hydrogen electrode should behave like cathode. And when hydrogen electrode behaves like cathode, this is the reaction, a reduction reaction. 2 times H positive plus 2 electrons gives H2. Right? This has to be the reaction. Now, N value is 2. If you want to calculate QC, QC is going to be pressure of H2, which I need to calculate, divided by concentration of H positive, raised power stoichiometric coefficient 2. Pressure of H2 I need to calculate, divided by, what is the concentration of H positive? Concentration of H positive is 10 raised power minus 7. 10 raised power minus 7 ka square will be 10 raised power minus 14. Do you understand? This is QC. Now the question is, we have to make a reduction potential 0. First of all, what is the formula to calculate reduction potential? Now this equation, reduction potential ERED is equal to E naught RED minus 0.0591 divided by N log of QC. This is the formula. Now we have to make this term 0. Reduction potential of hydrogen electrode, we have to make 0. This is already 0. This is SRP. SRP of hydrogen electrode is already 0. SRP SOP of hydrogen electrode, that's already 0. This term is already 0. Now we have to make this particular term 0 as well. For that purpose, in order to make this particular term 0, what has to be the value of QC? That's the question. What has to be the value of QC? So first of all, this 0, this 0. That means, what does that mean? That means 0.0591 divided by N into log of QC. This entire term will approach towards 0, will be equal to 0. When is that possible? That is possible only if QC value again is 1. Right? If QC is 1, then only log of 1 becomes 0, right? Then it makes sense. So QC has to be equal to 1. Do you understand, guys? What is QC? QC is pressure of H2 divided by 10 raised power minus 14. So this has to be equal to 1, which means that pressure of H2 has to be equal to 10 raised power minus 14 atm. So this has to be the pressure of H2. This has to be the pressure of H2. Then only the reduction potential of hydrogen electrode will become equal to 0. I hope this is clear. Okay, I hope this is clear. This question, you should tell me directly from the table which I gave you in the yesterday session, which I shared with you in the Telegram group. Again, if you are not the part of the Telegram group, be the part of the Telegram group right now. The name of the Telegram channel is Wassim But Chemistry Official. WASSIMBHAT Chemistry Official. What's the answer, guys? Guys, this question you have to do on your own. I cannot help in this question, right? So which gas is produced at anode when you do the electrolysis of dilute H2SO4 using platinum? It's oxygen gas, right? It's oxygen gas. A direct question from the table it was. Tell me, if 0.5 ampere current is passed, through a solution of acidified silver nitrate for 100 minutes, the mass of silver deposited. So for silver to be deposited, what should be the reaction? The reaction, silver will be deposited first of all at cathode, because at cathode reduction takes place. So in the solution, there will be Ag positive ions. They will go to cathode. They'll take 1 electron and get converted into Ag solid. This will be the reaction at cathode. At cathode, reduction takes place, gain of electrons. So current of how much amperes? 0.5 amperes is going into the solution for how much time? 100 minutes. So 100 into 60. So this is going to be in seconds. What is the mass of silver deposited? So mass of silver deposited as per Faraday's first law will be equal to equivalent mass of silver multiplied by I multiplied by T divided by 96500. Equivalent mass of silver will be molar mass of silver divided by n factor of silver. What is n factor of silver? 1 divided by 1. That's 1 multiplied by 96500. I value is how much? I value is 0.5. Time is 6000 seconds. Solve this, you'll get the answer in grams. This is the mass of the silver deposited, right? Again, the similar sort of question. Okay. This question we have already solved. Can you tell me what is going to be the answer of this question? Limiting molar conductivity of NH4OH. NH4OH means NH4 positive, OH negative. So NH4 positive, OH negative. NH4 positive, OH negative. So you have to add those substances which have got NH4 positive and OH negative with them and subtract the rest. So NH4 positive plus OH negative. This is NH4 positive here. This is OH negative. Just add them and subtract the rest. So it has to be option 4 directly. Do you see, guys? Do you see the method which I gave you yesterday? What do we need? We need NH4 positive and OH negative. So NH4 positive is here, but OH negative is not here, right? OH negative is here, NH4 positive is not here, right? In the last case, if you see NH4 positive and OH negative, you are adding and subtracting the other one. So directly, that's going to be the answer. Directly, that's going to be the answer. Can you solve this question? Can you check it out? The equivalent conductance of M by 32 molars, 1 by 32 molar solution of a weak monobasic acid is 8 Simon centimeter square, and at infinite dilution it is this. The dissociation constant will be what? Do you remember dissociation constant, or you call it as ionization constant, right? Dissociation constant or ionization constant. So since we are talking about the acid, so dissociation constant of the acid. I gave you yesterday one formula. I gave you yesterday one direct formula, if you remember. That was, I think, C lambda C square divided by lambda naught M into lambda naught M minus lambda MC. Do you remember this result I gave you yesterday? Yes? Now, if you look carefully, concentration is given to you as 1 by 32 molar. This is the concentration. I mean, this is the molarity, right? And at the same time, when the concentration is 1 by 32 molar, molar conductance at that point of time is given. So lambda MC is given to me as 8 with the units. And lambda naught M is also given to me at infinite dilution. How much is that? That's 400. So all the three values you have, put them here in this expression, get the Ka value. I gave you this result yesterday. Okay. So with this, electrochemistry is over. Let's take the dinner break. I'll meet you exactly at 10:30. But I want everyone to be back, okay? So at 10:30, we'll start the questions of kinetics. Okay? I would want every one of you to be back on time, guys. Okay? Do not skip the session at all. At all means at all. I'll see you exactly at 10:30. Guys, can you hear me? Am I audible, visible to everyone? Again? Yes? Yes, I'm 4 minutes late. I know that. Where do I keep this? Should we move on, guys? Should we move on? Should we move on? Quick in the chats. Should we move on already? Already. Perfect. I hope all of you are ready with your pen and paper, huh? Chalo, let's move on. Let's get going. My dear students, first question on your screen. From the chapter, Chemical Kinetics. If the concentration of H2O2 changes from 0.5 molar to 0.05 molar in 15 seconds, then calculate the rate of the reaction. Also calculate the rate of appearance of O2. Okay? The reaction is given to us. First of all, if I write the differential form of rate for this particular reaction, I'll write rate of reaction is equal to, with respect to H2O2, I'll start with minus 1 divided by stoichiometric coefficient is 1. Change in the concentration of H2O2 divided by time interval delta T. Now, rate of the reaction with respect to water, I'll be starting with plus sign, 1 divided by 1. Change in the concentration of water divided by time interval delta T is equal to, with respect to O2, I'll start with plus sign, 1 divided by, stoichiometric coefficient is 1 by 2. So 1 divided by 1 by 2 comes out to be 2, right? Delta O2 divided by delta T. So basically, all these three terms are giving you the rate of the reaction. All these three terms are giving you the rate of the reaction. Now, the data of H2O2 is given. So let's calculate rate of reaction from this particular term. So I'll write rate of the reaction is equal to minus times change in the concentration of H2O2. Will be final concentration of H2O2 minus initial. Final is 0.05 minus initial is 0.5 divided by time interval is given in the question, that's 15 seconds. So solve this particular term, you will get the rate of the reaction in moles per liter per second. This is the rate of the reaction. Correct? This is the rate of the reaction. Now, my dear students, second question, calculate the rate of appearance of O2. Calculate the rate of appearance of O2. What I'll do, I'll just equate this term with this term. If I equate these two terms, I'll write 2 times delta O2 divided by delta T. It has to be equal to minus times delta H2O2 divided by delta T. Right? This 2 can go to the denominator. So I'll write delta O2 divided by delta T is equal to minus 1 by 2. Change in the concentration of H2O2, which will be again final concentration of H2O2 minus initial concentration divided by time interval, that's 15 seconds. You just need to solve this particular term. When you solve this term, what do you get? You get delta O2 by delta T. Delta O2 by delta T is called as the rate of appearance of O2, which you were supposed to calculate, that too in moles per liter per second. Am I clear with this? Simple question this is. Right? I'll move on to the second question. Look at this question, guys. Calculate the rate of the reaction in the interval 5 to 15 seconds. In this particular time interval, I have to calculate rate of reaction. First of all, as you can see, with time, concentration is decreasing. And with time, concentration of reactant decreases. And reactant is your NH3 basically. So basically, this is the graph which is valid for NH3. Now, rate of reaction with respect to NH3, I'll start with minus 1 divided by 2, stoichiometric coefficient 2, change in the concentration of NH3 divided by time interval delta T. Right? So I'll write minus 1 by 2 as such. Now, what is the change in the concentration of NH3 in this time interval? At 5 seconds, concentration of NH3 is 0.6 molar. At 15 seconds, concentration of NH3 is 0.2 molar. So final concentration of NH3, which is 0.2 molar, minus initial concentration of NH3 divided by time interval is 5 to 15, that means 10 seconds. Solve this term, get the answer in moles per liter per second. This is your rate of the reaction. Again simple. Yes. Again simple. Again a simple question. Moving on to the next question. I think this question we did in the yesterday's session. Anyways, the ones who have not seen this question, let's exactly solve this particular question again. So first of all, you are given with the reaction. Some data is given to us. We have to get the relation between K1, K2, K3. So write the differential form of rate. I'll say rate of the reaction is equal to, with respect to N2O5 minus 1 by 1 change in the concentration of N2O5 divided by time interval dt. With respect to NO2, it's going to be plus 1 divided by 2 change in the concentration of NO2 divided by time interval dt is equal to plus 1 by 1 by 2, which comes over to 2 d of O2 divided by dt. Now this particular term, its value is given to me in the question, that is K1 multiplied by concentration of N2O5 is equal to 1 by 2 d of NO2 by dt. d of NO2 by dt is equal to K2 multiplied by concentration of N2O5 is equal to 2 times d of O2 divided by dt is K3 multiplied by concentration of N2O5. So can I say N2O5 everywhere gets cancelled out? So I got K1 is equal to K2 divided by 2 is equal to 2 times K3. So take the LCM of the denominators. When you take LCM of the denominators, the value comes out to be 2. And I'll be multiplying throughout with 2. So it becomes 2 times K1 is equal to K2 is equal to 2 2s are 4 times K3. So this is the relation between K1, K2 and K3. Correct? Clear with this? Yeah? Perfect, guys. Let me move on to one more question. Look at this particular question. The question is, you are given with the chemical reaction A gives B, whose rate constant is K. It is found that the rate doubles when the concentration of A is increased 4 times. Calculate the order of the reaction. Let the order of the reaction is equal to N. Let the order of the reaction is equal to N. Okay. Now, can I write the rate law? Rate law says that R is equal to K, concentration of A raised power N. This is your rate law. Let me call this as equation number 1. Now the question says rate doubles. Rate doubles. So rate becomes 2R. When the concentration of A is increased 4 times. So it was A earlier. Now it's 4 times A. Let me call this as equation number 2. Just divide equation 2 with equation 1. When you divide equation 2 with equation 1, R and R gets cancelled. So on left side you get 2. K and K gets cancelled. A power N gets cancelled. So you are left with 4 raised power N. What should be the power of 4 such that it comes equal to 2? So power of 4, that is N. That should be 1 by 2. Then only LHS RHS will be equal. So N is equal to 1 by 2 means order of the reaction is equal to 1 by 2. Yes? This is how you deal with such kind of the question. Perfect? Now, tell me the answer of this particular question. You are given with the reaction. Let me write the reaction again. It is BrO3 negative plus 5 times Br negative plus 6 times H positive. It gives 3 times Br2 plus 3 times H2O. This is the reaction. Okay. The rate of disappearance of bromine, the rate of appearance of bromine is related to rate of disappearance of bromide. Right? We have to get the relation between Br negative and Br2. So now write the differential form. I can say rate of the reaction with respect to Br negative will be minus 1 by 5 change in the concentration of Br negative divided by time interval dt. Now the rate of reaction with respect to Br2, it's going to be plus 1 by 3. It's going to be d of Br2 divided by dt. Now find the options. Find the options, people. Quick. So in the answer, there should be minus. So it can be either A or D. Rest, in any of the case, there is no minus on one side. Okay. So I'll write one thing. Take this 3 here. It becomes minus 3 by 5. D of Br negative divided by dt is equal to d of Br2 divided by dt. Do you see this option somewhere? d of Br2 divided by dt is equal to minus 3 by 5 d of Br negative divided by dt. It's option 4. That's the correct answer of the question. Right? I believe this sort of a question you can easily solve. This sort of a question you can easily solve. Tell me the answer of this question. The reaction is given to us as A plus B gives P. Okay. Now it is mentioned that rate is doubled when the concentration of B is doubled. And rate increases by the factor of 8 when the concentration of both A and B are doubled. Rate law for the reaction can be written as. Rate law for the reaction can be written as. That's the question. Yeah. So first of all, if I write the rate law is going to be R is equal to K, concentration of A raised power X, concentration of B raised power Y. This is your equation number 1. Now the question says rate doubles. The rate doubles. So rate becomes 2R when the concentration of B is doubled. So A you are keeping as such. Instead of B you are writing 2 times B raised power Y. This is equation number 2. Now rate increased by the factor of 8. So earlier it was R. Now it becomes 8R. When rate becomes 8 times, when the concentration of A as well as B both are doubled. So instead of A, I'm writing 2A. Instead of B, I'm writing 2B. Raised power Y. So this is equation number 3. So if I divide equation 2 with equation 1, what do I get? If I divide 2 with 1, so RR gets cancelled. So I'll be left with 2 on the left side is equal. K and K cancels out. A raised power X, A raised power X cancelled. B raised power Y, B raised power Y cancelled out. So I'm left with 2 raised power Y. So Y value comes out to be what? Y value comes out to be 1. Right? Now, what you can do is, you can divide equation 3 with equation 2 as well. If you divide equation 3 with equation 2, RR gets cancelled, 8 by 2 comes out to be 4, K and K gets cancelled, this term gets cancelled, A raised power X, A raised power X cancelled, this is 2 raised power X. So what should be the power of 2 such that LHS R becomes equal? So X value has to be 2. So you got X2, Y1. So what should be the rate law now? Rate law should be R is equal to K, concentration of A. Concentration of A raised power X, X is 2. Concentration of B raised power Y, Y is 1. So this is your rate law now. Yeah? Correct? So it's option D, that's the correct answer of the question. I believe this is also clear to everyone. Tell me the answer of this question. This you should be able to solve on your own. This you should be able to solve on your own. For the reaction between A and B. The reaction is between A and B. Okay, the reaction is between A and B. For example, A plus B gives P. The order with respect to A is 2. The order with respect to A is 2. And the order with respect to B is 1. Okay, so write the rate law. R is equal to K. Concentration of A raised power X. X means order with respect to A. Order with respect to A is 2. And order with respect to B is 3. This is the question. Order with respect to A is given as 2. Order with respect to B is given as 3. Now, the concentration of A and B are doubled. So you are making it 2 times. You are making this also 2 times, right? Concentration of A and B both are doubled. So when this becomes 2 times, this becomes 2 ka square, this becomes 2 ka cube. 2 ka cube is 2 to 4 to 8 and 8 4s are 32. So rate becomes 32 times. Simple. Rate becomes 32 times. Correct? Correct, people? I believe this is clear. So you're doubling A as well as B. So this becomes 2 times. This also becomes 2 times. So this is 2 ka square, which is 4. 2 ka cube, which is 8. 8 4s are 32. So the rate of the reaction is going to increase 32 times. Perfect. Now, what do you think about this particular question? Tell me the order of this particular reaction. The reaction is 2A plus B gives C plus D. So, if I try to solve the question like this, understand. In your experiment number 2 and experiment number 3, concentration of A is kept constant. B is doubled. Concentration of B is doubled. Rate is increasing 4 times. So, when you are doubling the concentration of B, rate becomes 4 times. That means power of B should be 2. Simple. When you are doubling the concentration of B, rate is becoming 4 times. That means power of B should be 2. So that 2 ka square will be 4 times, right? Now, if you look at this experiment and this experiment, what has happened? Concentration of B is kept constant. A is increased 4 times. Concentration of A is increased 4 times. What is happening to rate? Rate is also increasing 4 times. So on increasing the concentration, of A 4 times, rate is becoming 4 times. That means power of concentration of A has to be 1, right? So R is equal to K, concentration of A raised power 1, concentration of B raised power 2. So this is the rate law, simple. Did you understand? How did I solve this question? Yes? Can you solve this one? For a zero order reaction, 20% is completed in 10 minutes. In what time it will be 80% completed? Right? So yesterday I gave you one trick for zero order. So time taken to complete 20% is equal to 10 minutes. Okay? We have to calculate time taken to complete 80% of the reaction. This is to be calculated. Let this be X. Let this be X. Right? Okay? So when you divide the two, what do we do? A shortcut. 0, 0 cancels out. It becomes 2 by 8 is equal to 10 divided by X. So X will be 40 minutes. This was the shortcut. This was a trick which I gave you in the last session. Okay? This was a trick which I gave you in the last question. Right, people? Perfectly done? Okay, let's move on to one more. Tell me the answer of this particular question. I want the answer from you because you are not supposed to use pen and paper in this question. It's understood. When the initial concentration of reactant is doubled, the half-life of the zero order reaction becomes. Do you remember how do we calculate half-life of the zero order reaction? Half-life of the zero order reaction is A0 by 2K. So half-life and initial concentration of reactant, they are directly proportional. So when initial concentration is doubled, the half-life will be doubled too. When you make this 2 times, this becomes 2 times directly proportional, right? Yes, so it's doubled. When the initial concentration of reactant is doubled, I would say half-life of the reaction is doubled too. Yeah? Okay, look at this question. Rate constant of the reaction A gives B. Reaction is A gives B. Its rate constant is given to me as 0.6 into 10 raised power minus 3 moles per liter per second. If the concentration of A is 5 molar, concentration of B after 20 minutes, that means concentration of product after 20 minutes. I gave you a result yesterday. Concentration of product at time t for a zero order reaction is nothing but K multiplied by T. So concentration of B at 20 minutes will be equal to K. K is 0.6 into 10 raised power minus 3 multiplied by T. T is how much? 20 minutes. So 20 convert it into seconds multiplied by 60. So the value comes out to be 0.72 molar. So this is the concentration of product, concentration of B, which is formed after 20 minutes. So answer is option D. If you just remember the results, you are done. If you just remember the results, you are done. Okay? What about this particular question? A first order reaction is 75% completed. A first order reaction is 75% completed in how much time? 100 minutes. You know, T 75% is equal to 2 times the T half for first order. So can I say T half will be equal to 50 minutes? Absolutely. Now what do we have to calculate? We have to calculate time taken to complete 87.5% of the reaction, which is 3 times the half-life, right? This result I have given you. So it's going to be 3 times half-life is 50. The value comes out to be 150 minutes. So time taken to complete 87.5% of the reaction is 150 minutes. They can ask you anything. For example, if they ask you time taken to complete 90% of the reaction, you know that is equal to 10 by 3 times T half, right? T half is given, put the value, get T 90%. They can ask you to calculate time taken to complete 99.9% of the reaction. That's equal to 10 times half-life. Half-life you calculated, multiply that with 10 and you are done. So anything can be asked basically out of all these. Okay, anything can be asked out of all these. Okay, look at this particular reaction. For an elementary reaction, the question is mentioned that we have got an elementary reaction. X gives Y plus Z. If the reaction is elementary, yesterday I told you for elementary reactions, order and molecularity are equal, right? For an elementary reaction, order and molecularity will be the same. So first of all, what is the molecularity of this reaction? 1. That means the order of this particular reaction will be also 1. So it's a first order reaction. Okay. Now, T half is given. T half is given as how much? 10 minutes. The question says, in what period of time would the concentration of X be reduced to 10%? In what period of time would the concentration of X be reduced to 10%? That means they are asking you technically to calculate the time taken to calculate 90% of the reaction. They are asking you this. Because when 90% reaction gets completed, at that point of time, 10% of reactant will be left. They are asking you that. How long will it take to reduce the concentration of reactant to 10% of its initial value? So that means they're asking you to calculate the time taken to complete 90% of the reaction. And you know, time taken to complete 90% of the reaction is nothing but 10 by 3 times the half-life. Half-life is given to me in the question. That is 10. 10 into 10 is 100. 100 by 3 is 33.3. So in 33.3 minutes, 90% reaction would have got completed. That means in 33 minutes, I would say in 33 minutes, 10% of reactant would be left. Yeah? Do you understand? I hope this is clear. Look at this particular question. This question was asked few days back in JEE Mains examination. The same question, ditto, same values. An organic compound undergoes first order decomposition. So let's say you have got an organic compound that's undergoing first order decomposition. Okay. Time taken for its decomposition to 1/8 and 1/10 of its initial concentrations are T1 by 8 and T1 by 10 respectively. What is the value of T1 by 8 divided by T1 by 10 into 10? Understand how this sort of equation will be solved. At time T is equal to 0, let the initial concentration of reactant is A0. This would be 0. Now they are defining two times. One is T1 by 8, one is T1 by 10. These are the two times they are defining. This is the time when the concentration of reactant reaches 1 by 8th of the initial concentration. So at T1 by 8, the concentration of reactant would be 1 by 8th of A0. So this is the concentration of reactant left at T1 by 8. Now T1 by 10, this is the time when the concentration is reducing from A0 to 1 by 10th of A0. This is something which is mentioned in the question. And the concentration of reactant left, I am representing with 80. So how many conditions I got? I got 2 conditions. These are the 2 conditions which I got. Right? These are the 2 conditions which I got. These are the 2 conditions I got. At T is equal to T1/8, the concentration of reactant left is 1 by 8th of A0. At T1/10, the concentration of reactant left is 1/10 of A0. Now, I hope you remember your integrated rate equation. T is equal to 2.303 divided by K. It is supposed to be log of A0 divided by 80. Right? Now, put this condition in this particular equation. Instead of T, I'll be writing T1/8 is equal to 2.303 divided by K log of A0 divided by, what is AT value in this condition? AT value is A0 divided by 8, right? So A0 A0 cancels out, 8 comes up, it becomes log 8, it becomes log 8. Log 8 means log of 2 raised power 3. Log of 2 raised power 3 means 3 log 2. 3 log 2 is 3 into log 2. Log 2 is 0.3. So 3 into 0.3 is 0.9. So I'm multiplying this with 0.9. Calling this is equation number 1. Now, if you put this particular condition here, in this particular equation, instead of T, you'll write T1/10 is equal to 2.303 divided by K log of A0 divided by 80. A0 as such divided by, what is 80? 80 is A0 by 10. 80 is A0 by 10. So first of all, A0 A0 cancels out, 10 comes up, log 10 is 1. Log 10 is 1. So this becomes my second equation. What value do I need to calculate? I need to calculate the value of T1 by 8 divided by T1 by 10 into 10. This value I need to calculate. What is the value of T1 by 8? T1/8 is 2.303 divided by K into 0.9. T1/10 is how much? 2.303 divided by K. Multiplying with this 10. So this particular term cancels. 0.9 into 10 comes out to be how much? It comes out to be directly 9. Yes? Right, people? I hope this is also clear. I hope this is also clear. Can you tell me the answer of this question? Simple. A first order reaction has the half-life of 1 minute. T 1 by 2 is equal to 1 minute. Time required for 99.9% completion. T 99.9% is equal to 10 times half-life. We already know that. So the answer is what? 10 into 1. That is 10 minutes. If you directly remember the result, you are done. Nothing to, there is no need to use the formulas and all, and etc. etc. Yeah? If you directly remember the result, you are sorted. Okay. Look at this question. Look at this question. What amount of reactant for the first order reaction will be left after 3.5 minutes? So after 3.5 minutes, what amount of reactant will be left? And amount of reactant left is represented by AT. So I have to calculate at 3.5 minutes what amount of reactant is left. And I hope you remember, amount of reactant left at some time t is nothing but A naught divided by 2 raised power n. Correct? And what is n? N you already should be knowing. It is total time divided by t half. Total time divided by t half. How much is total time? Total time is 3.5 minutes. Now what do I need? I need t half. How do I calculate t half? T half formula for the first order is 0.693 divided by k. Now, in order to calculate t half, what do I need? I need k. To calculate k, a graph is given. Ln AT versus t. Ln AT versus t. What is the slope of ln AT versus t graph? The slope is equal to minus k. I hope you remember. Yesterday we have seen. This is 45. This is 90. So this is 45. So this angle has to be 135. So slope is basically tan of theta. And theta is basically this exterior angle, which is 135. This is taken as theta. So tan 135 is minus 1 is equal to minus k. So k value came out to be 1. K value came out to be 1. If k is 1, t half is equal to 0.693. Right? So this will be 3.5 divided by 0.693. The value approximately will be 5. So I got the value of n. If you got the value of n, concentration of reactant left will be A naught divided by 2 raised power 5. That means A naught divided by 32 molar. This is the concentration of reactant left after 3.5 minutes. Or you can say this is the concentration of reactant left after 5 half-lives. Okay? So basically, 3.5 minutes is how many half-lives? 3.5 minutes is 5 half-lives. So the concentration of reactant left after 3.5 minutes, or you can say the concentration of reactant left after 5 half-lives, it will be A naught divided by 32. Perfectly done? I hope this is also clear. Look at this question. Look at this question, guys. You are given with the reaction A gives P. Okay. Initial concentration, time T is equal to 0. Initial concentration is represented by A naught, which is equal to 0.1 molar. Which becomes 0.001 molar in 5 minutes. So at T is equal to 5 minutes, the concentration of reactant becomes 0.001 molar. And the concentration of reactant left at any time is represented by AT. What do we have to calculate? Rate constant? Simple. K is equal to 2.303 divided by T log of A naught divided by AT. Now, T is given, A naught is given, AT is given. Put the values, get the rate constant. That's it. Everything is given basically. Right? Everything is given in the question. All right. For the first order reaction, choose the correct value of half-life. For the first order reaction, you know half-life is nothing but 0.693 divided by K. So to calculate half-life, what do I need? I need K. How do I get the K? K I'll be getting from this graph. The graph is between log AT versus T. The graph is between log AT versus T. And the slope of this particular graph will be how much? Slope of this particular graph is minus K divided by 2.303. And slope is nothing but tan of theta. And theta is this exterior angle, which is 135. Tan of 135 is minus 1. So minus K divided by 2.303 is equal to minus 1. Or you can say K is equal to 2.303. Right? Time is in minutes. So it will be minute inverse. So you got K. Put the value of K here. 0.693 divided by K value is 2.303. The answer is going to be 0.3 minutes. So this is the half-life of the reaction. Now they can ask you anything. They can ask you now, T 99%, which will be 10 times the half-life. T 75%, 2 times the half-life. T 87.5%, 3 times the half-life. T 90%, 10 by 3 times half-life. T 99%, 20 by 3 times the half-life. Right? I believe it's clear. Okay. These are some repeated questions. Just a second. Okay, look at this one. Look at this question, guys. Try to solve this. The question is a first order reaction, A gives B, for example, has the rate constant of how much? 2.303 into 10 raised power minus 3 second. If you again use the integrate rate equation, there was a lag, I think, huh? Now I think it's fine. Is it fine now? Okay, now it's okay. See now. So basically, the initial amount of reactant was 40 grams. How much time will it take for the amount of reactant to reduce from 40 grams to 10 grams? Right? Initially, at time t is equal to 0, the initial amount of reactant is 40 grams. Now, how much time will it take for the amount of reactant to reduce from 40 grams to 10 grams? And the amount of reactant left at some time t is represented by 80. I just need to use the integrate rate equation. You know, t is equal to 2.303 divided by k log of a naught divided by 80. So I would say t is equal to 2.303 divided by k value is how much? K is 2.303 into 10 raised power minus 3 log of, what is a naught? A naught is 40. What is 80? 80 is 10. So this becomes log 4. Log 4 is nothing but 0.6. So this 2.303 cancels. 10 raised power 3 comes up. So the answer is going to be 600 seconds, right? So approximately 600. So actual will be 602 seconds. So it will take 602 seconds. It will take 602 seconds for the amount of reactant to reduce from 40 grams to 10 grams. Got it? Look at this question. Just do one thing. Ignore the options. I'm just going to make calculation a bit easy for you. Just take it as 2.303 into 10 raised power minus 3 seconds. Okay. Now tell me the answer of the question. Leave the options aside. Okay. I just made calculation a bit easy for you. Now you tell me the answer in the chats. You tell me the answer in the chats now. $300 seconds, is that? Let's see. Let me check whether you did it correctly or not. Let's say again you have got the reaction A gives B. For example, at time t is equal to 0, the initial concentration of reactant is A naught. Now we have to calculate time taken to complete 2/3 of the reaction. Time taken to complete 2/3 of the reaction. Time taken to complete 2/3 of the reaction. What does that mean? That means 2/3 of reactant would have got converted into product. If at this time 2/3 of reactant has got converted into product, how much reactant would be left? I had taken A naught. Out of A naught, 2/3 of A naught is getting converted into product. So I'll be left with A naught minus 2 by 3 A naught. The value comes out to be A naught by 3. So this is the amount of reactant left. This is the amount of reactant left. And amount of reactant left is represented by AT. Correct? This is the amount of reactant left at T 2/3. Okay? Now guys, understand. Since I got my condition, if you got the condition, this is your condition, right? If you got the condition, use it in the integrate rate equation. What is your integrate rate equation of the first order reactions? You know T is equal to 2.303 divided by K. K is how much? Not by AT. A naught as such, AT is A naught by 3. And this T will be T 2/3. So T 2/3 will be equal to how much? This term cancels out. A naught cancel, 3 comes up. Log 3 is 0.47. 0.47 into 10 raised power 3 will be 470 seconds. So this is the time taken for 2/3 of reaction to get completed. This is the time taken for 2/3 of the reaction to get completed. Is it clear? Again, let me repeat. Initially, the amount of reactant was A naught. We are supposed to calculate time taken to complete 2/3 of the reaction. That means 2/3 of reactant would have got converted into product. I started with A naught. Out of A naught, 2/3 of A naught got converted into product. How much reactant will be left? A naught minus 2/3 of A naught, which will be A naught by 3. Now use the integrate rate equation. Put this condition here. You'll get the answer. That's it. Okay? That's it. Look at this particular equation. This sort of equation, again, I showed you in the yesterday's session. I hope you remember. I hope you remember. The reaction is given to me as A gas gives 2 times B gas plus C gas. At time t is equal to 0, pressure due to A is P naught. This is 0, this is 0. Now at time t, pressure due to A will be P naught minus X. 1 gives 2, so X gives 2X. 1 mole gives 1 mole, so X gives X, right? So I got the partial pressures of reactants and products at time t, right? Now, I'm defining a term that is PT. PT is the total pressure of the mixture at time t. Since at time t, there are 3 gases in the container. At time t, there are 3 gases in the container. So I would say at time t, there's a mixture of gases present in the container. And the total pressure of the mixture at time t will be equal to P naught minus X plus 2X plus X. So I would say PT will be equal to P naught plus 2X, or you can say X is equal to 1 by 2 PT minus P naught. You got the value of X? You got the value of X? Right? Again, at time t is equal to 0, there will be only one gas in the container, that is gas A. So whatever is the pressure that's due to A, that's P naught. This is 0, this is 0. Now, as the reaction proceeds, pressure due to A will decrease, pressure due to B and C will increase. So at time t, pressure due to A will be P naught minus X. 1 mole gives 2 moles, X gives 2X. 1 gives 1 mole, X gives X. Right? So at time t in the container, there will be 3 gases. So the total pressure of the mixture at time t will be this plus this plus this. From this, I got the value of X. Now people, if you understand carefully, I'm going to write the rate constant expression. That is 2.303 divided by T log of. It used to be A naught by AT. But instead of A naught is initial concentration of reactant. Now I'll use initial pressure of reactant, which is P naught, divided by AT. AT used to be concentration of reactant left at time T. AT used to be concentration of reactant left at time T. Now, over here, I'll use pressure of reactant left at time T, which is P naught minus X. It used to be A naught by AT. A naught used to be initial concentration of reactant. So I use initial pressure of reactant. Divided by AT used to be concentration of reactant left at time t. So here I'm using pressure of reactant left at time t, which is P naught minus X. Now, K will be equal to 2.303 divided by T. It's going to be log of P naught divided by P naught minus X value already I've calculated. That's half of PT minus P naught. Okay. This 2 can go here. It becomes twice P naught plus P naught. Makes it 3 times P naught. So it's going to be 2.303 divided by T log of this is 2 P naught minus this divided by 2. So that 2 comes up. Just a bit of calculation, nothing else. So 2 P naught divided by, it's going to be 3 P naught minus PT. Do you see any expression like this? Do you see any expression like this? Which one? 2.303 divided by T log of 2 times P naught divided by 3 P naught minus PT. This is the option. Yeah? Some log values you have to remember. Like log 1, log 2 till log 10. Yesterday, in detail, I've told you how these sort of questions are solved, right? Okay. This is again the question, right? Whose concept I gave you in the yesterday session. I hope you remember. I give you one result in the last class. That is T half 1 divided by T half 2 is equal to A1 divided by A2 whole raised power 1 minus n. I hope you remember. I hope you remember, right? So this is basically your T half 1. Call this as T half 2. Call this as A1 and call this as A2. Put the values. T half 1 is 4 divided by 2 is equal to A1 by A2 is 50 divided by 100 whole raised power 1 minus n. So this value is 2 is equal to, this is 1 by 2 raised power 1 minus n. I can say 2 is equal to 2 raised power n minus 1, right? When is this possible? This is possible only if n minus 1 is equal to 1. So you can say n value is equal to 2. So order of the reaction is nothing but 2. That's something I was supposed to calculate. Simple. Okay. Perfect. Now, which equation you should use to solve this question? Which equation do we use to solve this particular question? Can you tell me that? Rate constant at temperature 227. I think this question we solved yesterday, right? This question we solved yesterday. I'm not solving this question again. It'll be the same. Log of K2 divided by K1 is equal to EA divided by 2.303R 1 by T1 minus 1 by T2. This question we solved yesterday. T1, T2 both are given, but we have to take T1, T2 in Kelvin, and K1, K2 is also given. K1, K2 is also given. You have to calculate activation energy EA. We solved this question yesterday, I believe. I believe we solved it. Okay, we solved it yesterday. Like this. Using this particular equation. Okay. Can you tell me the answer of this one? The rate of the chemical reaction doubles for every 10 degree rise, okay? If the temperature is raised by 50 degrees centigrade, the rate of the reaction increases by about. One equation I gave you in the yesterday session, R2 divided by R1 is equal to 2 raised power delta T divided by 10, right? So R2 divided by R1 would be equal to 2 raised power delta T. How much temperature is increased? It is increased 50 degree divided by 10. So I would say R2 will be equal to 2 raised power 5 times R1. So the rate of the reaction has increased 32 times. When the temperature is increased, by 50 degree, right? Rate of the reaction would have increased 2 raised power 5 times, 32 times. Correct. Good. Okay. So what would be the answer of this question then? Similar sort of question. If the temperature is increased from 10 degree to 100 degree, the rate of the reaction will become, so R2 is equal to 2 raised power delta T, change in temperature, final minus initial, that is 90, change in temperature divided by 10 multiplied by R1. So R2 will be simply equal to 2 raised power 9 times R1. Equation you have in front of you, right? 2 raised power 9 will be how much? 512 or 256? It will be 512 times. Tell me the answer of this particular question. Tell me the answer of this particular question, guys. Reaction is A gives B. Enthalpy of the reaction is negative. Enthalpy of the reaction is negative. Enthalpy of the reaction is negative means reaction has to be exothermic. Enthalpy change is coming out to be negative. That means reaction has to be exothermic. Right? And in case of exothermic reactions, graph comes down basically. I hope you remember. Yesterday we saw the graph starts like this and goes down in exothermic reactions. In endothermic reactions, the graph starts from here and would be here. This is for endothermic. This is for exothermic. Now you check, where is the graph going down? Where is point B downer than that of A? That's here. So option B, it's correct. Yes? Okay, tell me the answer of this question. For producing the effective collisions, the colliding molecules must. This is something which you should be telling me from there only. Discussed in detail yesterday. Quickly, everyone. Everyone means everyone. Which is the most appropriate? Most appropriate. First of all, there are two factors which decide whether the collision is effective or not. One is energy factor, one is orientation factor. Right? One is energy factor, one is orientation factor. Right? So it's going to be option D. Threshold as well as orientation. Perfectly done. Tell me the answer of this question. The reaction X gives Y is an exothermic reaction. X gives Y is an exothermic reaction, okay? Activation energy for the conversion of X into Y. X into Y means activation energy of forward reaction is equal to 150 kilojoules. Enthalpy changes, delta H is equal to 135 kilojoules. But since reaction is exothermic, so delta H sign has to be negative. We have to calculate activation energy for the reverse reaction. We have to calculate activation energy for backward reaction. I gave you one result in the yesterday's session. I hope you remember. Delta H is equal to EAF minus EAB. EAF minus EAB. Delta H is minus 135. EAF is 150. So minus EAB. EAB needs to be calculated. So I would say EAB will be equal to 285 kilojoules. This is EAB when you solve it. Right? So absolutely it's option B. All of you are perfectly right. Good. Tell me the answer of this particular question. The question has been asked in NEET 2019. You have got a hypothetical reaction whose activation energy is 0. I told you yesterday, K is equal to A, E raised power minus CA by RT. Since for a hypothetical reaction whose activation energy is 0, this particular term becomes 0. If EA is 0, this term is 0. Anything raised power 0 is 1. So K becomes equal to A. K becomes equal to A for the reaction whose EA is equal to 0. That reaction whose activation energy will be 0, I would say its K is equal to A. That means K is temperature dependent or independent. K becomes temperature independent. There is no temperature here in this relation now. So K becomes temperature independent. So on changing the temperature, nothing happens to rate constant. So whatever was the rate constant of the reaction at 200 Kelvin, same is going to be the rate constant of the reaction at 400 Kelvin. So the answer is going to be same, 1.6 into 10 raised power 6. Right? Perfect. I believe this is clear. I believe this is clear. Tell me the answer of this one. The activation energy of the reaction can be determined from the slope of which of the following graphs? From the slope of which of the following graphs? I hope you remember yesterday, guys, this is something which you should be able to solve on your own. This is something which I told you yesterday in detail. If you remember, ln of K is equal to ln of A minus EA divided by R multiplied by 1 by T. So for example, I have to plot a graph between ln K and 1 by T. Let's say plotting this along y-axis, this along x-axis. So this becomes M, the sign is minus, and this is C. So y is equal to minus mx plus C. Y is equal to minus mx plus C. So you are plotting a graph between ln K and 1 by T. Y is equal to minus mx plus C. The graph is like this, right? And the slope of this graph will be equal to what? Minus CA by R. Slope of this graph is equal to minus CA by R. So slope of ln K versus 1 by T. Right? From that slope, you can calculate activation energy. It's not C, it's A. ln k versus 1 by t graph. The graph is between ln k and 1 by t, which we made yesterday. Ln k versus 1 by t, its slope is minus EA by R, right? So from the slope, you can calculate activation energy. Yeah? Perfect. Can give this a try. Can give this question a try. Give this question a try. Again, the slope of ln k versus 1 by t, which I told you a few minutes back, that is minus EA by R. This value is given to me as minus 5 into 10 raised power 3. 10 raised power 3. So you can say your EA value will be equal to 5 into 10 raised power 3 R. We have to get the answer in kilojoules. If we have to get the answer in kilojoules, so 5 into 10 raised power 3, R value is 8.314 joules per Kelvin per mole. So right now the answer is in joules. I need the answer in kilojoules. So dividing it with 1000. Now the answer will be in kilojoules. So this 1000 gets cancelled. Answer will be 8 5s are 40. 40 something. 40 something. So this is the answer. Right? I hope this is also clear. So these were the types of the questions that can be framed from the chapter chemical kinetics. Okay? These are the types of the questions that can be framed from the chapter chemical kinetics. Right, people? Should we go on to solution now? Should we go on to solution? I hope all of this is clear. I'll give a separate PDF for formulas also, no worries. I'm going to give you the PDF of these sessions for yes. Someone has already solved this question. The answer is 88. Is that? Or you will try the questions of solution on your own if I send you the PDF. Yeah? I can keep a doubt clearing session on Zoom. You give them a try then, huh? Okay. This question is simple. PS is equal to P naught A chi A plus P naught B chi B. That's it. Mhm. 88 torr is the correct answer of this question. 88 torr is the correct answer of this question. All right. So the questions of solution, I mean the PDF of this particular, you're going to give it a try on your own. Okay, of the chapter solution. And wherever you face any sort of difficulty in solving, I'm going to conduct one uh, Zoom session day after tomorrow, right? So wherever you face difficulty in solving these left out questions, you can let me know in that particular. Okay, the link of the Zoom session I'll send you in the Telegram. Done? Done, people? Okay, okay, okay. But give it a try, okay? Don't leave these questions as such. Give them a try. Give them a try. Give them a try, okay? So wherever you face any sort of difficulty in these questions, in the remaining questions, okay? In 1 to 2 days, I'll be conducting a Zoom session for that. I think you should be able to solve them on your own. And wherever you face any sort of difficulty in solving the rest of the questions, you can let me know in that Zoom session. I hope this session was beneficial for all of you. Yes, if this was beneficial, if you want similar types of the questions after every marathon, do let me know in the comment section of this particular video once the, okay? Do let me know in the comment section of this particular video. These questions are enough, more than sufficient, more than sufficient, more than sufficient. And Sunday, exactly at 10 a.m., I'll be having a marathon with you. That is class 11th inorganic chemistry complete, right? Okay. And right after this sessions, the ones who have not liked that particular session, class 11th inorganic, do smash the like right now so that you may remain notified about all the things. Hello guys, I'm taking leave then. I'll see you guys day after